Hello everyone, I'm Priyansh Patnagar, and in this video we will talk about the introduction to the major project, which is search engine with DFS based web crawling. So what is a search engine? So search engine is a tool. It's a tool that allows user to search for any information, right? Any information, or we can say some images or facts or videos and etc., right, on the internet. So it's a tool which allows user to search for anything that is present on internet, right? So a very well-known example for this tool is google.com. So everyone would be aware that what is google.com, right? So you can search for anything, literally anything. So if you want to search for any information, you can just go to the google.com and search on the search bar and click on the search button, and you can get the results according to that, right? So in this particular playlist, we are going to implement a simple search engine. Okay, we are going to implement a simple search engine, and we are going to understand how a search engine is made, how every functions of a search engine is working behind the screen. Okay, so let's have a quick demo of the project, that how our project will look like after making. Okay, so let's go to the site. So this is our particular web application. So in this we have our title, and we have our search bar, and we have our search button, right? So when we search for anything, so what I have done here, for simplicity, I have only added the functionality for Java T-point websites. Okay, so I've only added the functionality for Java T-point pages. Okay, Java T-point pages. So now if I search for anything, suppose if I search for React here and click on search, okay, so I'm going to get the best results according to the React. Okay, best results of Java T-point sites according to the keyword that I have entered. Okay, so you can see the React.js tutorial is on the top and the least relevant tutorials are on the bottom. So what it does, it basically presents me the top 30 results, according to the user query. Okay, so that is the function of our project. So the first function is to perform search, right? To perform search, in which we get top 30 results according to the user query. Okay, and the second function is the history feature. When I click on history, it is going to show me the previously searched queries of the user. Okay, so you can see in the last I have searched for React. So, and when I click on this link, it will redirect me to the search page of that query. Okay, also if I want to visit any of these particular results, I can just click on the link that is to the side of the result, and when I click on this, it will redirect me to the Java T-point site. Okay, so that is the gist of the project. Okay, so these are all the features that we'll be doing. So second feature is going to be to get the user search history, right? So we only have two functions for simplicity. Okay, so to perform search is going to be a complex function. Okay, it is going to contain so many algorithms. So that's why we have only put two functions for this particular major project. Okay, so what web application comprises of comes before understanding the technology stack of the project. Okay, so we need to understand what our web application is going to contain. Okay, so a general web application, if we talk about a general web application, it contains generally three major components. The first one is going to be the front end side of the application. Okay, the second one is going to be the back end side of the application. Okay, and the third is going to be the database. There are also some minor components that helps in scaling and making the application fast, but these are the three major components that is comprised in the web application. Okay, so what are these components, how these components actually work, and how they play their roles in the web application? Let's understand them. Okay, so what is front end and back end? Okay, what is front end and back end? So front end and back end have the same relationship as the client to server relationship. Okay, so if you know what client and server relationship is, client is basically the one which asks for something, okay, which makes a request, okay. It's make a request for some data. It can make a request for some data. It can make a request for to perform some calculation. It can make a request to perform some major operations. Okay, so he will ask the server to perform all of the operations that he cannot perform. Okay, so client will ask the server to perform an operation. Okay, so it makes a request to performing operation. Okay, now what server does, it basically handles the request and generates a response. Okay, it handles the request and generate the response to the client. So this is the client server relationship. Okay, this is the client server relationship that we talk about. So what front end back end is, it is the client side. It is the client side of the application. It is the client side application. And what backend is, it is the server side application. Okay, it is the server side application. So this client side basically makes a request to the server side, and server side handles the request of the client and generate a response according to the request. Okay, so it can be anything. So a client can ask to make a request for adding two numbers, right? Suppose it asks to ask the server to add two numbers. Now servers handle the request, and he knows that the formula for adding two numbers is z equals to x plus y. Okay, and it generates a response and gives the z value to the client back. Okay, so this is a very basic example that we can get. To understand more what front end and back end is, take an example of a restaurant. Okay, take an example of a restaurant. Okay, so in a restaurant, what we do, we go to a restaurant. Okay, we go to a restaurant, and in that restaurant we sit on a table. Okay, we sit on a table, and we wait for the waiter to come and take our order. Okay, we sit on the chair, and we wait for the waiter to come and take our order. Okay, so think of this restaurant as a web application, as a complete web application. Okay, think of this restaurant as the complete web application. Now the waiter comes and serves the user requirements. Okay, so this is the client side of the application. Okay, it is interacting with the client. Okay, so this is the client side of the application. Okay, because it is interacting with the client. Okay, so front end and back end are the client side applications, right? So what happens is a user basically interacts with the front end. Okay, it interacts with the front end because it is the client side application. Okay, and front end sends the request to the server. Okay, to the server, sends the request of the user to the server. Okay, so this is the server side application in which server takes place. Okay, this is the client. Okay, and clients make requests to the server. Okay, a user interact with the client side of the application, and it basically interact with he can just push a button, he can just submit a form, and the front end, the client side of the application, sends a request to the server, and server fulfills the request, right? Fulfills the request if it's possible, right? Now if we come back to the restaurant example, so we wait for the we basically sit on the chair and interact with the waiter. Okay, interact with the waiter for giving for asking our food, right? That I want this, I want this, I want this, right? So waiter will note down our order and tell to the chef, right? Tell the chef that my client my user wants this thing. Okay, suppose I order for a pizza here, right? And the waiter goes to the chef and tell the chef that user wants a pizza. Okay, so you can think of this waiter as a client side application, and think of this chef as a server side application. So because there's a server side application, it has to handle the request of the user. Okay, it has to handle the request of the user, right? So it makes the food, whatever is requested by the user. Okay, so it makes the food, and what waiter does, waiter takes this food and give it to the user. Okay, so a user always interact with the front end of the application, right? A user always interact with the waiter, not with the chef. Okay, so that's why waiter is always a client side application. Okay, and chef is portrayed as a server side application. So yeah, and what is database? What is a database? So database is something like a storage of data. Database is a storage of data. So sometimes backend cannot perform operations on its own. It might need some data. It might need some external data to perform some actions. Okay, suppose the front end has asked the backend that I want all of the COVID patients that I want a number of COVID patients that till now. Okay, so backend does not have this capability to find out the COVID patients. Okay, so it needs to check the storage of the data, that how many COVID patients have been I have been there. Okay, so backend can put a simple formula for adding two numbers, but it cannot know the number of COVID patients, right? So we might need an external data for that purpose. So that's why database is used as a storage of data. Okay, so database is used as a storage of data. In this example, in this restaurant example, think of this as a refrigerator. A refrigerator for making the food. It is storing some of the food, some of the raw food, and the chef is using this raw food to cook the food. Okay, and then the waiter provides the food to the user. So this is the complete flow of a general web application. So in the previous video, we discussed about what will be the components will be there of a web application, right? So in our application too, we will be having a front end, okay, a front end, a back end, and a database. Okay, so let's discuss the tech stack that we will use individually for each component. Okay, so for the front end part, we will be using the HTML. I guess some of you might be familiar with HTML language. So what is HTML? HTML is a hypertext markup language. Okay, so what it is used for? It is basically used to create the skeleton of a web page. Okay, so you can see it creates a skeleton of web page. Okay, you guys you guys should know that what is the difference between a web page and a website. So a web page is basically only a single page, and website is a collection of web pages. Okay, so using an HTML file, you can create only one single page. Okay, for creating different pages, you have to use different HTML files. Okay, so HTML basically is used to create the skeleton of the web page, or we can say the structure of the web page. Okay, and for the front end part, we will also be using CSS. CSS stands for cascading style sheets. Okay, what it is used for, as the name suggests, it is used for styling of the web page. Okay, so the background color of the web page, or font color of the web page, table alignment, text alignment, and so on. Okay, last thing that we will be using is the JSP. JSP stands for Jakarta server pages, or we can say Java server pages. JSP is the code that we will be using for connecting the front end to the backend. Okay, for the interaction between the front end and the backend. So JSP will be doing that part. So what JSP actually is, it basically helps us to write Java code inside HTML file. Okay, inside HTML file. So it helps us to write Java code inside the HTML file, which basically connects the front end web page to the server, okay, to the backend server. Okay, so JSP basically helps us to set up the interaction between the front end and backend. Okay, so that was the part for front end, and for the backend we will be using only one tool, that is Java Servlets. Okay, so we'll be using Java Servlets for backend part. Okay, so what Java Servlets is, it basically helps us to create so many mini servlets. Okay, so many mini servers, we can say. Okay, so it helps us to create servlet. What servlet is, so we can divide this server to backend server, the complete backend server, to several different servers, several different mini servers. Okay, several different mini servers. Now suppose if the user want to add two numbers, and the server has the capability to perform all of the calculation, all of the type of calculations. Okay, so he has the servlet for adding two numbers, he has a servlet for multiplying two numbers. Okay, he has a servlet for subtracting two numbers. Okay, now if the client provides a request for adding two numbers, he will trigger that servlet that is assigned for the adding purpose. Okay, so yeah, so Java servlets basically helps us to create so many different servlet classes. Okay, so these servlet classes act as a mini server. Okay, mini backend server. Okay, that was the only tool that we are going to use for the backend part. And for the database, that is the collection of the storage. Okay, that is the collection of the data. Okay, so we'll be using MySQL for this purpose. Okay, so MySQL is my structured query language. It basically used for writing queries to interact with the database. Okay, so it's a DBMS system, database management system. Okay, so yeah, MySQL is a very popular tool for creating database and interacting with the database. And yeah, we will be using MySQL for our purpose. Okay, so what you have to do, you have to first install the IntelliJ IDEA Community Edition. If you have not installed, install it right now. So when you have installed it, you have to just open it and click on the new project. Okay, and when you click on the new project, you have to select the generator Maven Arch type here. Okay, so this is necessary. Maven archetype is necessary to select. It helps us to create a dependency management framework. Okay, so what is dependency? I will tell you in some time. Okay, here what you need to do, you have to just put your project's name. So let's put it search engine. Okay, and here we have to create it on whatever location you want. Okay, select OpenJDK 18. Okay, it will take some time to detect some SDKs. Okay, so if you want to add some more JDK, you can just download it from here, and otherwise you can select any JDK you want. Okay, but make sure you select only one JDK for whole project. Okay, after selecting the JDK, leave catalog as it is and select the Maven archetype to be Maven archetype web app. Okay, this part is very important. You have to select the web app because it creates the Maven framework according to a web application. Okay, so we have to select the Maven archetype web app. Okay, after selecting it, you have to just click on create. Okay, so here let's see what we have. It will take time to setting up the project. Okay, okay, it will take some time to for this src folder to appear. Okay, and when you go to src folder, you will have a main folder, and inside a main folder you have a resources folder in which you can have different photos or images, videos, gifs, files, audios, whatever you can use for your web application. Okay, and inside this web app folder, this will be containing all of our JSP codes. Okay, all of our HTML pages and JSP pages. Okay, now you can see we have already have a sample index file, and in this index file we are having an HTML file which is saying h2 tag of hello world. So it's an header tag and that is saying hello world. Okay, now this is the most basic code for creating a web application in Java. Okay, now this pom.xml file tells what the dependencies the project is having. So it is telling the Maven repository that what are the dependencies that the project is depending upon. Okay, so what do I mean by dependencies? The project can depend on some other projects. Okay, some other projects, or we can say some other libraries. Okay, which are basically built for other projects to use them. Okay, suppose you can have a library to parse HTML pages. Okay, you can have a library to parse HTML pages. You can have a library to have a library for anything. Okay, you can have a library to add two numbers. Okay, so it's just classes. These are just classes that are not present in our project. We are just taking help from these classes that are publicly available on Maven. Okay, that are publicly available on Maven. So whatever dependencies our project is having, okay, that is discussed in this pom.xml file, because this file is used for dependency management. Okay, so right now our project is by default having the dependency JUnit, so it is used for creating test cases in Java. Okay, so yeah, if you want to remove this dependency, you can remove it, but yeah, you understand the point that why we are using the pom.xml file. Okay, now to run this complete web application, you have to install a plugin. Okay, you have to install a plugin called Smart Tomcat. Okay, you have to go to file. Let's repeat the step. You have to go to the file and go to settings, and when you go to settings, you have to go to plugins, and when you go to plugins, you have to search for Smart Tomcat. Okay, When you search for Smart Tomcat, you have to install it. I have already installed it, so I'm not installing it, but you have to install it. Okay. When you install it, click on apply and click on OK. Fine. Now, to run this application, let's understand what is a host server. Okay, let's understand what is a host server. So, a host server is a server that is hosting our complete web application. Okay, so it contains our complete web application. Okay, now suppose I go to my browser. This is my browser. Okay, and I click on google.com, or I click on any URL. Okay, suppose I click on google.com. So what happens is browsers sends a request to the Google's hosting server. Okay, to the Google's hosting server. Now, what this Google's host server is having? It is having the Google web application. Okay, it is having the complete code of Google web application, whatever it needs. Okay, it is hosted publicly on internet. That's why we are able to access it. Okay, so Google is hosting the web application. Now, when I click on google.com, I want the home page. Of this particular application. So when I click on this google.com, this Google host server sends me a response with Google homepage, Google's homepage, and our browser show that Google homepage to us. Okay, so that is what is happening. That is what the function of host server is. Okay, so everyone is interacting with the Google's host server. Everyone is interacting with the host server of web applications. Okay, that's why you are able to access the websites, different websites. Okay, so we need a similar host server. To deploy our application. Okay, so what we will be using for that is Apache Tomcat. Okay, what it will do? It will host my web application on my local system, so I can test it in my local system. Okay, so that is what we are using Apache Tomcat for. Okay, so we need to download this particular Apache Tomcat server, which will be used as a host server for our application, and we can test our application on the local system. Okay, fine. So what we need to do? We need to go to our browser and search for Apache Tomcat. And when you go to Google and search for Apache Tomcat, what we have to do? You have to go to the download. Okay, when you go to download, make sure that you are downloading Tomcat 9, not Tomcat 10. Okay, because it is not stable, I can say. So we are going to use Tomcat 9. And when we go to Tomcat 9, you have to select in the binary distributions, you have to select the core one. Okay, and in the core, you have to select the zip file. Okay, let's zoom it. So you have to select this particular file. Okay, and when I click on this file, you have to download it and extract the zip folder. Fine. When you go to downloads, and it will download after some time, and you have to unzip it. Okay, click on extract all, extract. It will take some time to extract. Okay, so let's go to our editor, and while it is extracting, what we have to do, let's increase the view here. Okay, what we have to do, you have to go to this current file. Okay, you have to go to this current file, And when you click on this current file, you have to go to edit configurations. Okay, when you go to edit configuration, we will be setting up a configuration which will use Apache Tomcat to host our server. Okay, so we will not be running the current file. Okay, we will be creating a new configuration which will use Apache Tomcat to run the application. Okay, so here let's create a new configuration, and in this configuration you have to select Smart Tomcat plugin that we installed earlier, and here you can put any name on it. Let's put Apache Tomcat host server. Okay, and here you have to select the extracted file. Okay, you have to select the extracted file, whatever extract when you have extracted the folder, you have to select the one. Okay, now this is the extracted folder I have. Select the inside one. Okay, select the inside one and click on OK. Do not interfere with these values. Okay, do not change these values because these are important. And yeah, this is our deployment directory. So this particular web app folder will be deployed with this particular server. Okay, that's why we don't need to change it. It will be automatically added. And when you click on apply and click on OK, this complete application will be run by this particular configuration. Okay, now when you click on the Apache Tomcat host server and click on run application, it is going to host our server. So let's cancel this file because I already have extracted it earlier. So keep this file, cancel. Okay, fine. What you have to do, it will run something like this. In the console you can see there's a link that is showing up in the console, and what this link is, it is the link to our web application that we have created. Okay, so our web application, our basic web application has been hosted on our local system. Okay, so you can see we are having the index page content. Okay, so we already had a index page, and that was saying the hello world. So yeah, on the index page we are having the hello world. So you guys might be familiar with the working of a search engine, right? So you go to google.com. What you do, you are a user. Okay, you are a user, you go to google.com, you interact with its front end, right? So whatever HTML web page you are seeing, that is your front end. Okay, you are all because the front end part of the web application always interact with the user. You cannot interact with the backend directly. Okay, so yeah, you can see the front end is the client side of the application, so you interact with the front end side. So how does it look? There is a search bar, we can say. Inside the search bar we provide some keyword. According to that keyword, we have some results, right? When I click on search button, there is also a search button, right? There's also search button, and when I click on this search button, the results according to this keyword are shown to the user, right? So we can say we are having some results, right? So let's assume that there's a table. Inside this table we are getting some results. Okay, and that is shown to the user. Okay, now this will be our basic UI, we can say. So what we are having is the search bar. Okay, this is the search bar, this is the search button. When I click on the search button, you can say that this is the submit button. Okay, so this is the submit button of this short form. Okay, and when I click on this search button, it generates results, right? How does it generate results? That's up to the backend, right? So we will not be talking about, because this video is about basic UI, right? So yeah, we will be getting some results, and that will be done by the backend process. So we don't need to worry about it right now. So yeah, then front end show the results and show it to the user. Okay, so let's start building our basic UI. Okay, so how we are going to do this? Let's go to our web IntelliJ IDE editor, and here what we need to do is let's create a search bar. Okay, let's create, instead of this hello world, let's create a form, and inside this form, because we need a form type event. Okay, so what form does is like a form, what form means. Okay, so form, you go up to a registration desk, right? You take up a form and you fill it and you submit the data to the registration desk, right? So this is working similarly like that. Okay, now in this form you are having a text bar, right? You are having a text field, right? You can see this is the text field that we are having, and there's a button, that is search button. So let's create a text field. So text field, we create a text field by using input tag. Then you have to close it, right? And inside this input tag, you have to provide the type equals to text. Okay, you have to type equals to text. Now what we need to do is to create a button also. Okay, so we'll also be creating a button which will be submit type. Okay, which will be type of submit. So when I click on this particular button, it will submit the form to its whatever location it is assigned to. Okay, slash button, and here I write the text that will be displayed on the search button, or display on the button. Okay, we don't need text displayed in the input tag. We want it to be empty, right? So let's have an input tag and a button only. Okay, let's rerun this application now. You have to click on stop and rerun because your application was already running. Now all of the process will again happen and our website will be again hosted. And when you click on the URL now you can see instead of having the hello world, we are having a search bar and a search button. Okay, this will be behaving as a form. I have to write something here. I can write anything. So my name is Priyansh. Okay, and when I click on search button, it will submit a form. Right now we are not having any location that where this form should submit the data to. We'll assign it later on. Okay, fine. What is Java servlets and how we integrate Java servlets in our project? Okay, so like I told you in the technology stack part, Java servlets basically helps us to divide the backend server into different servlet classes. Okay, it will create different servlet classes. Okay, so it's a technology that we can use to create many servlets or many servers. Okay, now how do we integrate this Java servlets in our project? For that, you have to go to your IntelliJ, and in the IntelliJ, you have to add a library. You have to go to file and go to project structure and add a capability. Okay, here in the library section, you have to click on the plus button. Here you go to from Maven, because you need to download a repository. You need to download a library from Maven repository. Okay, here you have to search for Java X dot servlet dash API. Java X dot servlet dash API. When you click on search button, it will show a couple of libraries that are doing the same work, but we will be selecting a particular library. Okay, so it will take some time to show up the libraries, and when it shows the library, you have to select this one, Java X dot servlet colon Java X dot servlet dash API colon 4.0.1. So make sure you select this particular Java X servlet. Here, when you select this library, you have to click on OK, and it will download the particular API. Okay, and then you have to click on apply and click on OK. Now we have added the library to create servlets. Okay, now how do we create a servlet? For create a servlet, you have to go to your main folder, and inside this main folder you have to create a new directory. Okay, and in this directory you have to create a new directory called Java, and here this Java folder will be marked as sources. Okay, we should mark at sources because it will contain the servlet classes. Okay, here in Java we have to go to file again, we have to go to project structure again, and here we have to go to module section. In the module section, go to src, and inside the main you have to click on Java, and when you select the Java, mark it as sources. Okay, when you mark it as sources, the folder icon will appear as blue. Okay, and when it appears as blue, it will be able to store the Java classes. Okay, now inside this Java folder I am going to create a new Java class, and here let's create a class for, let's create a servlet for search facility. Okay, let's create a search class. Okay, now let's understand what is happening in the front end back end interaction in our project. Let's see. So we are having a user provides a keyword or a query to the front end, right? To the front end there's a search bar, there's a search button, and he writes up the query or keyword and clicks upon the search button. So this is our front end, right? Now what happens is what happens in the back end. Okay, so this front end tells that the user has given this query. Okay, so it will send a request to backend that I need to search for this keyword. Okay, I need to search for this keyword. Now backend triggers because backend is having so many servlets, right? Backend is going to have so many servlets. So suppose now we have created a new servlet for search. Okay, so it will trigger this particular search servlet, and it will get the response from that search servlet. Okay, it will provide the keyword. It will provide the keyword in the search servlet, and let's make this complete search servlet in the backend itself because it is contained in the backend, right? So let's have it in the backend. So this is the search servlet, right? Now this search servlet is responsible for generating the response to the front end. Okay, so this will generate the response to the front end. Okay, this will generate the response to the front end, and then front end will show this response as a tabular view or whatever view the front end is designed for. Okay, and it will show it to the user. Okay, so what happens in the front end back end interaction? Front end sends the request of the query, so sends the request of the user of its client, right, to the backend, and backend generates the response according to this request provided by the user, right? So now when I go to my search page, and here we are having a text field, I have provided some text, and we are having a submit button. When I click on submit button, the form gets submitted. Okay, the form gets submitted. Now here when it gets submitted, it will go to the search servlet. Now we are providing the action search servlet. When we click on submit button, this action will be triggered. Okay, now it will go to search servlet. Now we need to make this search.java to be a servlet. Okay, how do we make it a servlet? Before this class, we need to annotate it with a web servlet. Okay, so make sure you guys add the library first before using this annotation, otherwise it will not work. Okay, now inside this web servlet, you need to provide the path. You need to provide the path of the search route. Okay, so whatever action you provide, this should be same as this particular path. Okay, make sure you do this. right. Okay, so whatever action you provide this to this form, this should be same as this web servlet route. Okay, this is the route, like when we go to google.com, right? When we go to google.com, let's give you an example of a URL. When we go to google.com and search for anything, what is Java? Okay, when I click on this, so you can see the google.com's URL, after google.com there is a slash and there's a search, right? So you can see there's a route, this is the route that is producing the result. You can see that this is the route that is producing the results. So in our case, this will be the route that is going to produce the results. Is that clear? And if it's clear, this particular class search will be behaving as a servlet, a web servlet. Now we need to inherit the properties of HTTP servlet. Okay, this is important because that's how it is going to work like a servlet. And inside this search class, we need to make a doGet method. Okay, so protected void doGet method. So whenever the search servlet will be triggered, this doGet method will be called. And inside this doGet method, we will be having two things. First is HTTP servlet request and HTTP servlet response. So what are these parameters? So it's the general request of the client, right? It is general request of the client, right? And it is also having the response. So these request and response objects will be created when this search servlet will be triggered, and this search servlet will play with this request and response object, okay, to do its function. Okay, now what we will be doing in the index.jsp, when I click on the submit button, the form will submit to its section. Okay, whatever action that we provide, it will go to that part. Now as we have provided the action to be search, it will go to search servlet because this is our path, right? So it will go to search servlet, and here it will generate a request object and a response object. Okay, now servlet has got the request, that this is the request. Okay, this is the request, and inside this request I want this input to have a name equals to keyword. Okay, so what do I mean by this name? So whatever data that I enter in the input tag, whatever data that I enter in this input tag, that is considered to be a keyword. Okay, so now when I go to search.java and I do string keyword equals to request dot get parameter, and here I can get the parameter keyword. Okay, so this keyword, we are getting this particular thing. Okay, so we are getting this keyword. Okay, now when we go to the search and let's print out this keyword that we have got in the console, so that we can know that the front end has sent the keywords value to the backend. Okay, properly or not. Okay, let's run the application now. It might generate an error. Update pmx.xml file. Okay, you have to click on this second option, and when you click on the second option, you have to click on this load Maven changes option. Okay, and when you do that, it will work fine. This might happen because of adding the servlet library. So these cases happen. Now when I click on the URL, it is going to work fine. And now when I go to this search bar and I can put any of the text. Okay, so I can write any of the text, and when I click on the search button, now you can see in the URL that the search servlet has been triggered, and keyword has been provided this value, right? Keyword has been provided this value. Now you can see in the console that we have also printed the keywords value. Okay, we have also printed the keywords value. So what has happened is we have, so yeah, user has entered the keyword to the front end and front end has sent this search keyword to the user. Okay, search keyword to the user. The search servlet can also provide a response. Okay, so here we can have a response also. So what we can do is print writer equals to response dot get writer. Okay, before setting up the writer, what we need to do is, okay, let's have it out. Okay, before having the writer, let's set the content of the response to be of HTML type. Okay, now we will generate a HTML response instead of having it in the console. Okay, HTML. Now when I set up these HTML, what I need to do, out dot println, and here I want to give a h3 tag slash h3 tag, and I can have let's say this is the keyword you have entered. Okay, and here let's close the string and add the keywords value here. Okay, now here the get writer is showing the red line because we have not handled an exception. So you can put here throws IO exception. Okay, fine. Now let's stop and rerun and let's see when we go to the URL. Let's see if it works fine or not. We are having a search bar, we are having a search button. Now let's put anything in the chat. Let's put my name, Priyansh, and when I click on search button, so that this is the keyword you have entered. So this is Priyansh, right? So this is the keyword you have entered, and here I am having the keyword that I have entered. Okay, so what has happened here? That was the basic front-end and back-end interaction you have seen here. So front-end sent the request to the search that this is a keyword, and search has generated a basic response that this is the keyword you have entered. Right now we are not performing any search operation, right? We are just sending the keyword to that servlet, and servlet is just generating the response. Okay, so this was to show you that how front-end and back-end interacts and how they exchange data between each other. Okay, let's understand how our web application is going to work when a search query is made by the user. Okay, now what we can see here is we are having a search, we are having a structure of a search. Okay, structure of a search query. Okay, now don't mix with this front-end and front-end processor and back-end processor. Let's just write on it. Okay, just make it black. Okay, now here you can see this particular, the upper block, we can say this is our web application. Okay, this is our web application part. Okay, this upper block is our web application part. Now this is the backstory. This is the backstory. We will be talking about backstory in the later part of the video. Let's discuss that how our web application is going to interact with the user. Okay, now the end user, whatever the user is, now you go to the search engine page. Okay, so this is the search engine interface. You can say that this is your front end of the web application. Okay, this is your front end of the web application, right? The user provides a query to the front end, of the web application. Okay, now when you go to now what happens is this query is then given to the query parser. Query parser is your backend. Okay, you can say that this is your backend server. So it is going to search, it is going to perform the search operation. Okay, so this is your backend part of the web application. It is going to understand what the query the user has provided, and according to the query, it is going to search the results. Now where it is going to search the results? From the database, right? So you can say that this is the database. Okay, now inside this database I have a collection of pages. I have the thousands of pages here, and from that thousands of pages, or we can say millions of pages, right? Google.com has billions of pages, right? So that depends upon your database size. So I have so many web pages that are contained on the internet, right? Now what backend will do, according to the query of the user, the backend will search top 30 results, right? The backend will search top 30 results which are most relevant to the query, right? Which are most relevant to the query. How he does that? This is going to be done by the ranking algorithm, right? This is the ranking algorithm. Okay, so what happens is go to the database and looks for the most relevant top 30 results that is most relevant to the query, right? Now when we do this, when we perform the ranking out of them, okay, let's suppose that database is containing all of that pages data, okay, and when we perform the ranking operation, it will be sent to the user, okay, it will be sent to the front end part of the application, and then the front end will show it to the user, okay, it will generate the results to the user. Now let's continue to the backstory of the search engine. Now how this database gets prepared, okay, how do we get so many pages inside our database? That is also important, right? How do we do that? So let's understand the basic backstory of the search engine. Now how it is getting so many web pages, how it is getting so many data of the web pages of that is contained on the internet, right? So internet is not just an API that you can just download all of its web pages on a computer, right? That is not possible, because internet is a decentralized network, right? It's a decentralized network, and it's an interconnection between so many computers, right? So you cannot download the complete data on a single computer or something like that, right? So what you need to do, how do we get the pages that are contained on the internet? We make a new tool that is called a crawler, okay, that is called a web crawler, or we can say a spider bot, okay, or we can say a spider bot. So what this spider bot does, it crawls over the internet. What do I mean by the crawls? It goes through so many pages that are contained on the www, right, or we can say internet, and it gets the pages data, right? It gets the pages data, that what is the page's title, what is the page's text, whatever the pages contain, okay? So it parse the HTML pages, right? It parse the HTML pages, okay? Now as we are using Java for building the application, what our crawler will do, it will parse the HTML pages and convert all of the HTML objects to the Java objects, okay? It will convert all of the objects to the Java objects. Fine. Now this is the part of the crawler. How I do that we'll understand later, okay? This crawler crawls over the internet. It requests for all of the pages that are contained on the internet, okay? It does not do it in a single go. It crawls over the pages, okay? That's why we are saying that it's crawling, okay? So it crawls over the pages, and yeah, it gets the pages data, and it provides the pages data to the indexer, okay? It provides the pages data to the indexer. Now what this indexer does, it saves data to database, okay? So what it does is, so we are getting a HTML page, okay, we are getting a web page. Now it selects whatever relevant data that we can get, okay, whatever relevant data that is important for finding the relevance, okay, that is very important for finding the relevance. Okay, so whatever relevant data that is needed from the web page, that is selected by the indexer, and it saves all of the data that is selected to the database, to the index file. Okay, now this is the complete story. So end user is interacting with our web application. It is not interacting with any of the scroller and indexer pods. What is the function of this scroller and indexer? They are just preparing the database. That's all. Okay, so they are just preparing the database. Now this web application is working on the same database and finding the search results according to the relevance of the page to the query. Okay, so that is the complete design of a search engine. Now this is going to happen in our case also. Okay, so yeah, that is the complete design of our web application. Okay, web application, and also we will be creating this web crawler tool to prepare our database also. So we'll be discussing about how a web crawler works. Okay, so let's discuss this. So okay, what we learned in the last video, that a web crawler is a bot. A web crawler is a bot that crawls over the internet, right? That crawls over the internet. That crawls over the internet to get the pages data, right? To get the pages data. We cannot do that manually, right? We cannot add page by page thing to the database, right? So we need a bot, we need an automatic bot that is going to do our purpose. Okay, so that is going to get the pages from the internet. Okay, now how he do that thing, do all of these things. Okay, let's understand that. So we'll be using an algorithm called DFS. Okay, how we use this DFS algorithm in that part. Let's see how we do this. So first of all, we visit a page. Okay, we start a page. We visit a page. This will be our starting web page. Okay, starting web page. Now this crawler bot, let's mark it as CR. Okay, this bot will go to this web page. Okay, let's mark it as W1. Okay, now this crawler bot will be accessing this W1 web page, right? This will be accessing this W1 web page. Now what it does, it parses all of it HTML objects. Okay, all of the HTML objects, and convert them to Java objects. That's what the meaning of parsing is. Okay, converts all of the HTML objects to Java objects. Okay, and that's up to the indexer that what HTML objects it needs. Okay, now crawler basically parses all of the HTML objects, and where it will go next, that will be decided by the DFS algorithm. Okay, now this is our starting web page. Now it will be connected to some other web pages, right? This W1 web page will contain some hyperlinks. Okay, what are hyperlinks? What are hyperlinks? Hyperlinks is a link. Hyperlink is a link that can, when we click on this hyperlink, it will redirect me to a different page. Okay, so it will contain some links, right? It will contain some links. Now when we go to this W1, we parse all of the HTML objects. Now while parsing this HTML objects, we also get the links present on the web page, right? The links present on the web page, and while we get these links present, these links will be connecting this W1 web page to some other web pages, right? These links will be connecting the web page W1 to some other web pages, right? Now what will happen after parsing the complete HTML page of this W1, right? This crawler bot will go to its children. So these links present inside this W1 are going to be considered as children. Okay, now this crawler bot will go to W2. Okay, it will Now parse, it will now process the W2 web page. It will now parse all of the HTML objects. It will also find all of the links that are present on the W2 web page. Now there will be some other pages that will be connected to the W2 web page, right? Let's say W5, W6, W7, right? Now the crawler will process the W5 here, right? After passing all of the crawler, after passing the W2 web page, right? It will go to this web page, right? So depth, what is DFS? DFS is depth first search, right? DFS is depth first search. Now, what do we mean by depth first search? We will be going to the depth first. Okay, we'll be going to the depth first. Before processing the another children, we will be going to the children of the children. Okay, so we'll be processing the children of the children before processing the second children. Okay, so that's what DFS means, right? So this is how we do all of the, this is how we process all of this stuff. Now suppose this was the end here, right? This was the end here. W5 is not connected to any of the other web pages. Now what will happen after processing the the crawler, after processing the W5 web page, this crawler will go to the W6 web page. Now it will go to the another children. Okay, now suppose this W6 is also not connected to any of the other children. Now this crawler bot will go to W7 web page. Okay, so what is the order? We can say that W1, we process the W1 first, then we process the W2 first, then we process the W5, W6, W7. So W2, W5, W6, W7, right? And suppose all of these web pages are not connected to anything. Now what we will do, we will go back, we will backtrack to W2. Now we will be checking that these are all of the web pages that it is connected to. We have already processed all of its children. Now we will backtrack to W1 web page. Now what will happen? We will be processing the another children. Okay. Now we'll be doing crawler W3. Now suppose it is not connected to any of the other web pages. Okay. So we will backtrack to W1 and then we'll process the another children. Okay. So now we process the W4. Right. So what is the order? After W7 we process W3 and then we process the W4. So this is what happens when we follow a DFS approach, right? Now what happens is okay, so using the depth first search, we are able to process all of the web pages that are contained on the internet, right? Now now let's understand that how the web crawler parses all of the HTML objects. Okay, so there's a library that we'll be using, okay, to parse the HTML objects. Okay, so that is called JSoup library. Okay, so JSoup library is used to parse HTML object to Java object. Okay, there are other libraries like Beautiful Soup for Python that will help us to parse HTML objects to Python objects, right? There are so many other libraries, right? So for our purpose, we are having the JSoup that will convert HTML object to Java object. Okay, so I think the algorithm is clear. It is plain depth first search, right? So what we are doing, we are at the root right now. And we are just then processing the children, right? We are processing the first children first, right? This is W2, this is W3, right? And then we are having some other children, right, of the W2, right? And here we are also having some other children, right? Now it will go to this W1 first, then W2 first, and then W5 first, right? Then W6 first, then W7 first, after that W7, then W8, W9, W10, right? So how this DFS goes? How this DFS goes? As we discussed earlier, it will go to the depth first, right? It will go to the root first. Okay. After going to the root, after processing the root, then it will get all of the childrens, W2, W3, and then it get all of the childrens, it will process the first children first. Okay. And then before processing the another children, it will process the children of the children of the first childrens, right? Now it will go to now in the starting it was at W1, then from W1 it goes to W2. Now from W2 it goes to W5. Now W5 has not any other web pages, so we can say that we can backtrack, right? We can backtrack and then we can process another children. Okay, W6 and W7. Now this was the same thing as we discussed earlier, right? Now suppose the tree is not limited. Okay, the tree of the web pages is not limited. Okay, it can be infinite, right? It can be infinite also. It can be so many web pages, like it is going to take so much time to process all of the pages, right? Now I have so many pages, so we can say that if we process the depth first, it is going to take so much time to get the all of the pages data, right? To get the all of the pages data. Now suppose I want only this this part of the pages. Okay, I want only this part of the internet. Okay, now if we perform a DFS approach, in this, then it will fail, right? It will take a lot of time. It will take infinite time because the height of the tree is infinite, right? If the height of the tree is infinite, then depth first search takes a lot of time to complete all of the web pages, right? Now, to make this more efficient, instead of using DFS, we are going to use depth limited search. Okay, we are going to use depth limited search. So this is depth limited DFS. We are going to use depth limited DFS. Now, what this depth limited DFS is, we assign a maximum depth. Now, what this maximum depth will be showing us, let's say if it is D, let's say if it is 3. Okay, this is depth equals to 1, this is depth equals to 2, this is depth equals to 3. Now what will happen? We will process the root first, and after processing the root first, we will process the children of this root, right? Now before processing the another children of the root, we will be processing the children of the children, like this one, right? Now when we go to the children of this children, we can say that the depth of this children, D equals to 4, is greater than the maximum depth that was assigned earlier. Now we can say that this is not going to happen. We have to backtrack. Okay, now we will backtrack, and as they are not and then we will go to the another children. Okay, and when we go to another children, we can say that depth is also equals to 4, and then if depth is also equals to 4, this is greater than the maximum depth, then we also need to backtrack here. Okay, now there are any other connected nodes, right? Now what we will be doing, we will be backtracking to the depth equals to 2 node, right? If we mark it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Now in the starting we processed the 1, and then 2, and then 4, and when after 4 we process the 8, but depth becomes greater than the maximum depth that was assigned, right? So we backtracked again to the 4, and then we processed 9, and depth was again 4, which was greater than maximum depth. So that's why we backtracked to 4. Now there was not any other children left that needs to be processed, so that's why we backtrack to 2 again. Now we will be checking another children of the 2. So we can say 5. Now depth equals to 3. which is equal to the maximum depth. So yeah, that's fine. Okay, so we will process it, we will process, it will be processed, it will be processed, and this 5 will also be processed, right? And then when we go to its children, depth also becomes 4, which is also greater than maximum depth. So that's how a depth limited DFS works. Okay, so it helps us to limit the depth of the tree. Okay, in our project we are going to use the depth limited depth first search, because we cannot get the, because internet is so big, right? Internet is so big, we cannot store all of the data in our local system, right? So that's why we are going to use a depth limited search. Okay, now if we are using depth limited search, let's understand what will be our pseudocode and what will be the algorithm. Okay, let's write the pseudocode for the algorithm that we discussed here. Okay, so we'll be creating a function that will be processing the HTML page. Okay, now inside this function I'm going to take 2 parameters. The first one is going to be the string. The first one is going to be the URL. Okay, and the second thing is going to be depth, because these 2 things we need to process. Okay, depth is also required because we need to check that if it is greater than maximum depth or not, right? And URL, because we need the URL of the web page that we need to visit. Okay, now what we will be doing, we will be creating a hash map. We will be creating a hash set. Okay, not hash map. Now inside this hash map, what I'm going to store? I'm going to store URLs. Now, why I'm using a hash set? Because it is not necessary that this complete thing is a tree, right? It can be a graph also, right? If W1 is connected to W2, there can also be an H from W2 to W1, right? W2 might contain a link that will go back to W1, right? So as this is a graph, we need to maintain a hash set so that we don't process the W1 again. Okay, so in the hash set, I'm going to store all of the URLs that has been processed. Okay, now let's call this hash set to be URL set. Okay, now if URL set contains the URL, that means this has already been processed, so we need to return. Okay, this is our base case. Second base case would be if depth is greater than the maximum depth. Okay, if depth is greater than the maximum depth, then also we need to return. Okay, then also we need to return. So these are all the base cases that we need to consider. Okay, because if URL set contains the URL, that means it has been processed, and if depth is greater than the maximum depth, then it don't needs to be processed. Okay, fine. After considering the base conditions, what we need to do, we need to increase the depth first. We will increment the depth. Okay, after incrementing the depth, now what we will be doing, we will be processing. Or we can say parse the HTML page, or we can say the URL that we are visiting, right? After parsing the URL, what we'll be doing, we will be sending it to the indexer, right? Or if we combine web crawler and indexer, that will be saving the URL page that we have got. Okay, whatever data that we have got from the parsing the URL, that will be saved to the database. Okay, now after saving the data to the database, what we need to do, we need to recursively call this function again for all of its children. Okay, so what we need to do, we need to get all of the links present. Okay, all of the links present from the data object, that we got from the parsing the URL, right? Data dot available links. This is not the syntax, I'm just writing the pseudocode. Okay, so whatever links that are present, for every link of this links present, we are going to recursively call the f function, right? We are going to recursively call the f function for the link that is present on the inside, and the depth, the incremented depth, because we have already incremented the depth. Now when we call this recursive function, it will be processing the children's of the web page. Okay, so this is the complete algorithm of a web crawler. Okay, this is the complete algorithm that we'll be using for web crawler. Okay, in the next videos we are going to implement the web crawler. So as we discussed in the last video, we discussed the pseudocode of web crawler, right? We discussed the complete algorithm of the web crawler, how web crawler does its thing, right? So let's go over it again, right? So what we need in our implementation, we need a hash set URL set, right? And we need a function f, right? We need a function f, and we need URL and depth also. Okay, when we are implementing this web crawler, we need things that we need, right? So as we discussed in the search engine design, that the web application is the one that the user interacts with, right? The web application is the one that the user interacts with. But this web crawler and indexer are completely different tools from the web application. Okay, so web crawler is not a part of a web application. Okay, so this will be a separate tool. Only thing that is linking these both tools is the same database, right? So web crawler saves all of the www pages to the database that is on which this web application is working, right? So what is happening is web crawler crawls over the internet, and indexer saves all of the www pages that is got by the web crawler and saves it to the database. Okay, and then end user searches for a query, and front end sends this query to the backend, and backend searched for the query in the same database that was prepared by this web crawler tool, right? And then this backend, the query parser, searches for all of the files, and according to the query, it ranks all of the pages and sends it to the front end, and front end shows the result to the end user, right? So in this particular video, we will be implementing this web crawler tool. Okay, and as I told you that this will be a separate tool, we need to create a new project here. Okay, now what we need to do here, we need to go to the file and create a new project. Now we don't need to select any of the generators here, okay, because we don't need to create a new web application. This will be a simple Java project. Here, click on new project and put name of your project, right? So let's put web crawler here and select whatever location you want. Select the language to be Java and build system to be Maven. Okay, not IntelliJ here. Build system should be Maven here. Okay, why Maven? Because we need some libraries on which this project depends upon, right? So why we are not using the Maven archetype? Because we don't need to create a web application or any of these archetypes. Okay, we just need some Maven system. Okay, we just need the Maven build system. So here, select Maven, select any JDK you want, and click on create. Let's open it in a new window. Okay, and in this new window, let's go to the main, and let's go to Java, and let's go to the main function. Okay, let's refactor this main class to be a crawler class. Okay, this will behave as a crawler bot. This will behave as a crawler bot. Okay, this particular class. We will be creating an indexer class also, and we will be creating a database connection class also. So for saving the files to the database connection, to the database. Okay. Now, what do we need to create a crawler? We need a main function because this will be our main class here. And okay, now in the crawler class, what do we need? We need a hash set, right? So that we can know that which URLs we have processed. And if we are processing an already processed URL, then we need to return from the function, right? So what do we need here? We need a hash set. Okay, we will be creating a hash set here. String URL set. Okay, and let's create a crawler constructor to create a URL set, to initialize this URL set. Okay, now what do we need to do? We have initialized our URL set here. We need to create our function f. We need to create our function f that will be behaving as a recursive crawler bot, right? So let's go to our IntelliJ and let's create this function. So let's have it public void, and let's call this function f to be get page text and links. Okay, now in this thing we need two parameters, string URL and string depth, or not string but integer depth, right? Depth will be an integer. This should be an obvious thing. So if URL set dot contains our URL, right, then we need to return that is true, right? If we have already processed this URL, then we don't need to process it again, right? Now if depth is greater than equal to maximum depth, okay, so we need to initialize a maximum depth also. So int maximum depth equals to, let's have it 2. Okay, and if depth is greater than equal to maximum depth, then what we need to do? We need to return. Okay, so fine, not greater than equal to, should be greater than, right? So as we discussed in this video code, should be greater than maximum depth. So let's have, for simplicity, let's have this maximum depth to be 2. Okay, and after checking the depth, that if it is greater than maximum depth or not, we will be incrementing the depth. Okay, now after incrementation, we have completed all of the base conditions here. Now what we need to do, we need to parse the HTML page to Java object. Okay, how do we do this? As I told you in the last video that we need a library called JSoup, right? We need a library called JSoup to parse HTML object to a Java object. Okay, so let's download this library from the Maven repository. Let's go to File, go to Project Structure, and go to Libraries, and click on plus button, and then select this from Maven. Now on the search bar, you need to search for JSoup here. It will take some time to search for the libraries. Now when we have searched for it, now it will show a couple of libraries with name JSoup. Now you need to search for this org.jsoup JSoup 1.15.4. okay, make sure to select this library, and when you select this library, click on OK. It will download this library, and click on apply, click on OK. Fine, now we have added this particular library. Now what we need to do, we need to parse the HTML object to Java object. Okay, now how do we do this? Let's select a document object, And make sure you select document object from JSoup library, not from Java Swing. Okay, so document, okay, equals to a document equals to, we need JSoup dot connect. Okay, we need a JSoup dot connect method, and we will connect to the URL whatever we have got from the parameter as a functions parameter. Okay, now here let's add a timeout of 5000 milliseconds. That means after 5000 milliseconds, if it is not able to connect to the URL, then we will proceed to the next URL. Okay, and then we will use a get method. Okay, now this JSoup will convert this URL, this HTML file, to a Java object. Okay, to a Java document object. Fine. Now what we can do is, as we have got a Java object, we can save it to the database, and that's work is for the indexer, right? That is for the indexer. Now let's leave it for indexer here. Let's put a comment for it. Indexer work starts here. Okay, now what we need to do, we need to get the links that are present on the data and process all of the links, and recursively call the f function on the link that are available on the current page, right? And put the increased depth that we increase, right? Fine. Now if we are let's print out for now the document title. Okay, so that we can know that if the crawler is working fine or not. Okay, now what we need to do, we need to get the available links on the page, right? So what we need to do, elements, links, available links on page, okay, equals to, let's have it capital O, available links on page. And how do we get it? Document dot select now what we need to do, we need to process all of the web pages, right? We need to select all of the links that are present on the current page and call the function f recursively for every link and put the increased depth that we increased here, right? Now let's do this thing. What do we need? We need an elements object. Make sure you select the jsoup.select, right? Elements, available pages on, sorry, available links on page, okay, equals to, what do we need to do is document dot select, and in the select, what do we need to select is the ahref. Okay, what do we mean by ahref here? So if you guys know, in the HTML there's a thing called anchor tag. Okay, there's a thing called anchor tag, right? Now what do we do with anchor tags? It will create a hyperlink. Okay, what do I mean by hyperlink? Hyperlink is the link that when we click on it, it will redirect me to another page. Okay, so in the anchor tag, in the HTML anchor tag, when we specify href, okay, when we specify href, right, when we specify href, this href will work as the URL, at which it will redirect. Okay, it will work as the URL that will when we click on this anchor tag, okay, when we click on this hyperlink, it will redirect it to this particular URL that is specified in the href. Okay, So what we are doing here, we are selecting all of the anchor text hrefs, right? So that's how we are selecting all of the available links that are present on this particular document, HTML document, by selecting all of its anchor text hrefs. Okay. Now what we need to do, let's have a for loop for each of the link, right? Element link, or we can say current link, available links on the page. And what we need to do, we need to call this f function, this get page text and links function, for each of this current link, right? So what do we do is get page text and links, and here what we need to do is current link dot attribute, and here we need to select the all of the absolute value of href. Okay, and here we need to put the increase depth. So what we are doing in this attribute function, we are just getting this href value here. Okay, we are just getting this href value as a string object. Okay, so this is this current link on its own, it's not a string object, right? It's an element object, right? To convert it to the string object, we need to use an attribute key, and what we need to select is the absolute value of href. Okay, so that's why we have used this attribute function here. So that's why we can get a string URL here. Okay, and then we have put the increase depth here, and we can call the function recursively. Now our crawler function is completed. We will be adding the indexer function later on. So let's see that if it is able to crawl perfectly or not. Okay, so let's call this function in the main. So let's initialize the crawler object first. New crawler, and what we need to do is crawler dot get available, get page text and links, and here we need to specify a link starting page. So let's add www.java.point homepage. Okay, and let's add the depth to be 1. Okay, so initial depth will be 1. Fine, and if it is greater than the maximum depth, we need to return. Fine. Now let's see if it works fine or not. Okay, let's run this application. So if it is able to crawl properly, it will print all of the document titles, or we can say the page titles. Okay, it is throwing a Java IO exception, so we need to handle it. How do we handle it? Let's set a try catch block. Let's add a try and catch block here. Java IO exception, and here IO exception dot print stack trace. Fine. And what we need to do is now run the crawler bot. So now you can see that if it is printing all of the titles, that is, it is able to crawl, right? It is crawling over all of the pages, right? And then we are just crawling over all of the pages here. Fine. So that's all about this video. We have created our own crawler bot, right? What we need to do here, we need to create an own indexer here so that we can save all of these document objects that we have passed from the URL to the database. Okay, so that we'll be doing in the next videos. So what is MySQL? MySQL, as we told you in the technology section that MySQL is a database management system. Okay, it's a DBMS. So it uses structured query language, structured query language, or it's short for SQL. Okay, it's uses SQL for writing queries so that we can interact with the database or we can manage the database. Okay, so in this particular project we will be using MySQL as our DBMS. Okay, so it will be storing all of our collections of data. Okay, it will be storing all of our collections of data. Fine. So all of our pages data will be stored in this MySQL. Okay, so before the indexing process I wanted to show you what MySQL is and what is and how do we interact with database. Okay, so let's open the MySQL workbench and let's understand and let's learn a basic couple of queries. Okay, fine. You go to the MySQL workbench and here you log into your local instance. This new query tab. Now when you open a new query tab, you can write queries in this query tab, right? And whatever query you write, you can just click on this particular button and it will execute the line. Okay, it will execute the line. It will execute the query. Okay, so what is the first query that I wanted to tell you is the create database. So we need to create a database first so that we can have a collections of table in it. Okay, so let's create a database called search engine and let's have a search engine application, search engine app. Okay, and here when I click on this particular button, it is going to create this database search engine app. Okay, now if I do show databases here, so it is going to show all of the database that has been created. Okay, now you can see here we can find the search engine app with database that we have created right now. Okay, fine. Now what we are going to do, we are going to use this database, use search engine app. Okay, now we have to execute this search engine app. Now after using this search engine app, we have to create some tables. Okay, so this is the database. Okay, so this is the database. Our search engine app is our database. Okay, so it is going to store a lot of tables. Okay, a lot of tables that we are going to create. In our application we are going to create only 2 tables, but yeah, database is a collection of tables. Okay, collection of data. Data are stored in a tabular format in a relational database management system. So MySQL is a RDBMS. Okay, what do we mean by RDBMS? It's a relational database management system. What do we mean by relational database? Relational database stores the data in the form of tables. Okay, in the form of tables. So all of the data are stored in the tabular format. So in the database, I am going to have collections of tables. Okay, collections of tables. So what do we have in tables? We have our rows. Okay, we have our columns, right? We have our rows. Fine. So in a database language, the columns are known as the attribute. Okay, columns are known as the attribute. So what do we mean by attribute? Like name can be an attribute, like age can be an attribute, address can be an attribute, right? So column is referred to as an attribute. Okay, and a row value is known as a tuple. Okay, a row is known as a tuple. Okay, so yeah, this was the basic for having a table. Now how do we create a table? You can go to your query tab, and here you can just run a command, create table. Now I'm going to create a table, my table. Okay, let's call this table my table. Okay, and open parenthesis. Now you have to specify attributes. What are the attributes this table is going to have? Okay, so suppose I'm going to have 3 attributes. The first one is going to be the name. Okay, the first one is going to be the name, and here let's say name is going to be of type varchar. Varchar is a data type of a character array. It creates a character array of this size. Okay, whatever size you provide, like I have provided 200, so it creates a character array of 200 size. Okay, now we can have an age, and it can be of integer type. Okay, and what we can have an address, or let's say let's have a phone number. Okay, and this also can be of type integer. Okay, now you have to add a delimiter here, that is going to be our semicolon. Now I am going to select all of these lines and click on this particular button, so it executes the selected portion of the script. Okay, now when I click on this, it has executed a query. It has executed my query, that is create table. Okay, now you can see when it is showing a green check mark, that means the query has been successfully executed. Okay, now when I select a star from my table, okay, what it does, it basically read all of the values that are present inside the table. Okay, so when I run this command, it is going to show the table. Right now we don't have any values in our table. The table is empty, right? To enter the values in the table, what we need to do, we need to use insert command to insert the values. Okay, so insert into my table values, and you need to provide values here. So let's provide values here. The first one is going to be the name, right? So you can have a tuple here. Let's put my age, and let's put my phone number here. That can be anything, right? It should be a number, it should be an integer. Okay, fine. And after that, when I run this particular command, okay, so you can see insert into table values, that has been executed properly. Okay, now when I run this command again, select star from my table, then it is going to show the values that I have entered here. Okay, now select star. What do you mean by star? Star means all of the attributes will be selected. Like means it will show name, age, and phone number that are present in the my table. Now if I wanted to show only a selected attribute, suppose I wanted to show only names from my table, okay, then when I run it, it is going to show only the name. Okay, if I want to select only name and age, then I can add a comma here, and I can run the command, and it is going to show the name and age. Okay, and if I want to insert another value, I am going to copy this and change the values. Let's add another name. Suppose I'm adding Ankit, right? Age can be 25. Comma can be a number. Okay, now here when I run this command, it is going to get executed, and when I run this command, when I read all of the values from the table, it is going to show the second value also. Fine. Now, so this is all the basics that we can use in the table, okay, in the MySQL. Fine. So this is all the basics you need to know right now. Fine. Now we have understood that how can we create the tables and how we can insert the data into it. Okay. Now, how do we interact? Okay, how do we interact with these tables from Java? Okay, how do we interact to these tables with Java? We can use Java. We can use a technology called Java Database Connectivity. So that's short for JDBC. So we are going to use a JDBC library that is going to connect Java to database. Okay, so we are going to use Java. We are going to connect Java to the database, and for that we need to use a JDBC library. So in our case, we are using MySQL as a database, right? We are going to use MySQL as database. So we need a library called MySQL connector /j. So it's a library that is going to connect the Java to the MySQL database. Okay, so we need to download this particular library to interact from Java with the database. Okay, to set up the interaction between Java and the database. So what we need to do, we need to download this particular library. Let's search for MySQL connector Java. Now we go to this particular site that comes up on the search page. Here we need to download this connector /j library to set up a JDBC driver to interact with the database. Okay, now here you need to select the platform independent and download the zip folder here. No time, just start my download, and after that you need to save it in your computer. Fine. Now when you go to your downloads, you need to extract it. Okay, you need to extract it. Fine. And now in the web crawler, let's set up the connection from the Java to the database. Okay, how do we do that? Let's create a new class. Let's create a new class called database connection. So this database connection class is going to set up the connection to the database. Okay, so this is going to create a connection instance to the database. Okay, it is going to create a connection instance. That will be used for writing queries from Java. Okay, right now we are running the queries from directly MySQL, right? But now we want to run queries from Java. Okay, so that's why we are setting up a connection from Java to the database. Okay, now before creating the database connection class, I want you to understand that database connection class it's going to be a singleton class. Okay, it's going to be a singleton class. Now what is singleton class? It's a pattern. It's an object-oriented pattern. It's an object-oriented programming pattern that creates a class. So it's a class with only single instance, or we can say single object. Okay, it is going to create only one object. Okay, it cannot have two objects or it cannot have three objects. Okay, why do we want to have the database connection to be a singleton class? Because when we set up connection from Java to our MySQL database, it is a costly operation. It is a costly operation in terms of computation power. Okay, so it's a costly operation. So if we don't create it as a singleton class, we can have different instances of connections. Okay, that is just doing the connection from the Java to the database. Okay, so we don't need that. That's why we are just having a singleton class which can only have a single connection instance to the MySQL. Okay, and then we can use the same instance to run query different times. Okay, so we don't need to create connection instance every time when we need to run the query. Okay, so we can use the same instance to run the query. Fine. So we can go to a database connection class and we need to follow the singleton pattern in order to create only one instance. Okay, now in the database connection class, what we are going to do here, we need to create a connection instance here. Okay, so let's create static connection. So connection from Java SQL. Okay, not org.json. Okay, make sure you select the right one. So static connection equals to null. So in the initial state, it was going to be null. Okay, So let's create a public connection get connection method that is going to set up the connection. Okay. Now, if the connection instance is not null, okay, if it is not null, that means we already have a connection instance, right? That means we need to just return the connection instance. Okay. And if it is not null, then we need three values. The first one is going to be the username of your MySQL. Okay. So in my case, it is going to be root. And the second thing is string password. In my case, it is going to be this, but you need to use your password. Okay, make sure you select your password instead of this. Okay, and after that, you need to use the database name. That is, in our case, is going to be search engine app. This is the database that we created right now, right? Now, what we need to do, we need to return get connection, and in this, I'm going to provide user password db. We have not created a get connection method that gets these parameters, so we need to overload this function. So this is going to be a private method connection get connection, and in this get connection method, I'm going to take three values. Okay, string username, string password, and string db. Okay, so now you can see that this get connection method is not same as this get connection method. Okay, so it's an overloaded version of this get connection method. Okay, so we are just overloading this get connection method, and in this we are taking three values. The first one is going to be user, password, and database. Okay, now in this, what we are going to do, we need the MySQL connector J library that is going to set up a JDBC connection, or we can say Java to the MySQL database connection. Okay. Now, how do we do that? We need to add a library that we downloaded from its site. So let's go to project structure, and here in the library section, we need to add a library. This time we don't need to select from Maven, we need to select from Java. Okay, because it's in our local system. So let's go to downloads, where you have downloaded it and where you have extracted it. So when you have extracted, it will show in this file explorer, and you can select, you don't need to select the complete folder, you need to select this JAR file. Okay, make sure you select the JAR file, and when you click on OK, it is going to add the library. Click on apply, click on OK, and now what you need to do, you need to get the class for name, and here you need to select the class, that is com.mysql.cj what was that? Yeah, .jdbc .driver. Okay, and here you need to select this class. So this class, this driver class that is present inside the library's code is going to get called here. Okay, now we need this driver class to set up a connection. Now here what we need to do, driver manager dot get connection. Okay, so we need to set up the connection instance here, and this will be saved into the connection instance that created here. Right, now in this get connection method, I need to create a URL that is going to be jdbc colon mysql colon / localhost / and here you need to add the database name, that is your DB, right? That is your DB, plus question mark your username, right? And here you will be adding your username, right? And your password. Your password will be equals to your password. Okay, so this is the complete value of the URL that you need to set up a connection. Okay, now we will be returning this connection instance when we call this get connection method. Now you can see that this for name and get connection method are throwing some exceptions. So let's try and catch block. Let's add a try and catch block. And here you need to set up a catch block and you need to use all of the exceptions. Okay, so there are two exceptions that you need to catch. The first one is going to be SQL exception dot print stack trace, and the second one is going to be the class not found exception that is thrown by for name. And if you are doing the same thing for every catch blocks, you can just collapse these catch blocks, right? You can just collapse these catch blocks here. Fine. Now here you need to return the connection, and this is the complete code you need to use to set up a connection to the database. Okay. Now that's it for this video, and we will be using this connection instance that will be created in the indexing method. Okay, so let's discuss about the indexing process in more detail. So what indexing does, what indexer does, indexer gets the www pages, or we can say the HTML pages, right, from the crawler, right, from the crawler. So crawler provides the www pages. We have already implemented the crawler part. Now what we have to do, indexer, what indexer does, indexer selects, first of all, it selects the important part of a web page. Okay, the important part of a web page. How do we select what's important? Whatever that is important to find the relevance, okay, to find the relevance of the page, with the user's query. Okay, suppose here user searches for a query, right, and users provides a query, and front end sends a query to the backend. Backend searches in the database for this query, okay, and it performs a ranking algorithm, right? It executes a ranking algorithm, and ranking algorithm, how do we rank the pages? How do we rank the pages? We need to find its relevance to the query, right? We need to find its relevance to the query. How do we find the relevance to the query? We select three things of a web page. Okay, we select three things of a web page. Okay, the first thing is the page title. Second thing is the page link. Okay, so these two things we need to provide in the result section, right? Whatever results that we need to show to the user, right, we need to show these two things. First of all, the page title and the page link, right? And the third thing that is important of a page is page text. What is page text? Complete text of the web page. Complete text of the web page. Okay, complete text of the web page. Now this will be used to find the relevance of the page. Okay, not title, not link, but the page text, whatever text that is contained inside the page will be used to find the relevance of the page, because page title can be misleading, right? If you want to use page title for finding relevance, that can be misleading. Okay, the title can be something and the page can be about, and the page can be about some other thing, right? So we need page text as the attribute to find the relevance of the page. So we need these three things of a web page, and what indexer has to do, it needs to save all of the important things to the database. Okay, it saves all of the things to the database, all of the important things to the database. So what we need to save? We need to save these three things of a document object, of the Java object that we got by parsing the web page, right? So how do we do it? Let's create a new indexer class to save all of these three things. Okay, and let's create a new class, indexer. Okay, indexer. Now in the last video, we basically created this database connection class. Now there's a small correction that you need to perform here. You need to add the static keyword before the connection instance. Okay, before the connection, you need to add the static keyword here. Okay, it's important because these functions, because connection is always going to be a static object. Okay, so if you are returning the connection instance, then the function should also be static, right? Fine. In the indexer class, what we need to do, we need three things. Okay, we need three things. First of all, the page title, the page link, and the page text. Now, when we get this document object, we can get these three things from this particular document. Okay. Now let's do one thing. In the indexer, let's have a connection instance. Let's set it null in the beginning. Now let's start the indexer first. Let's start the indexer constructor first. Now indexer constructor is not going to be a simple constructor. It is going to be a parameterized constructor. It is going to get a document object, the JSoup document object that we got by parsing the web page. Okay. Now let's get this document object. Now what we need to do, we need to save important. First of all, let's select all of these things. Select important elements of document object. Okay, so the first thing is going to be the title, equals to the document dot title. Okay, document dot title. Second thing is going to be the link. Okay, now here we need to provide the link also, because we cannot get that from the URL, right? So if we are going to call this indexer object from this crawler pod, we can provide this string URL here, right? And we can provide this document object directly to the indexer constructor. Okay, now string link is going to be the URL, and the string text is going to be the document dot text. Okay, now what we need to do is save these elements to database. Now what we need to do, we need to set up the connection equals to database connection dot get connection. So it calls the get connection method of the database connection that we created here. Okay, it calls the get connection method here. Now in the get connection method, we have got the connection instance. Now we will use this connection instance to save all of these elements to the database. How do we save the elements to the database? We need to use an insert command like we did in the my table. Okay, so let's create a table first in which we will be saving all of these things. So let's create a table first. Create table pages. Let's call this table pages. Okay, now in the pages table, I need three attributes because we are setting three attributes. The first thing is going to be the page title. The page title, let's have it varchar of 200. Okay, it's going to be a character array of size 200. Then page link. In the page link, let's have it of text type. So text is something like string object in SQL. Okay, and if I do page text, then let's have it of medium text type. Okay, so text by default is small text type. Okay, and medium text by default is a medium size text, and if I can do large text, that is going to be of large size. Okay, so I'm just doing it of medium text. So we need these three things of a page to store. Okay, we need these three things of a page to store because these three things are only important of a page, right? So let's execute this command. When we execute this command, you can see that there's a green check mark on 12th row. And now if I do select star from pages and run this command. You can see our pages table is empty right now, and we have already got the attributes. Okay, now page structure is clear to you guys. Now let's go back to the web crawler project, and in this we need to save these three elements of a document object, and we need to use the connection instance to run the query from Java to the MySQL database, right? So what query we need to run, that is the insert command, right? How do we do it? Let's create a prepared statement for that. Prepared statement equals to connection dot prepare statement. Now we need to prepare a statement. What do we mean by prepare statement? You will get it. Insert into pages values. Now the values are going to be dynamic, not static, right? The values are going to be dynamic, not static. Okay, the values are not static like this, right? The values are not static like this. The values are going to be dynamic. It is going to be provided by these strings, right? Every time. Now what we need to do? We need to prepare this statement. Now this statement, this query will be prepared. Okay, how do we prepare it? Now we will use this prepared statement dot set string function. Now at the parameter index 1, that means at the first question mark, we need to add 3 question marks here. At the first question mark, I want the page title. Okay, I want the page title. Similarly, prepare statement dot set string at parameter index 2, or we can say at the question mark, at the second question mark, what I want the URL, the page link, because when we go to this pages table structure, the first one is page title, the second one is page link, and the third one is page text. Okay, so at the second parameter index, I want URL, and at the third parameter index, I want the page text, that is going to be the text, right? And after setting all of the strings, the statement is prepared. Okay, the statement is prepared. At the first question mark, we have the titles value. At the second question mark, we have the URLs value. At the third question mark, we have the text value. Now after setting all of the things, the statement has prepared. Now we will execute the update of this prepared statement. Okay, now you can see that all of these statements are throwing some exceptions, so we need to add these things in a try catch block, and we need to catch the SQL exception that they are throwing. SQL exception dot print stack trace. Okay, now you can see we have used the connection instance to run an insert command from the Java, and now we have executed the update. Okay, so this is the complete function of indexer. Now this will be happened whenever we call the indexer object, whenever we initialize the indexer object, and its constructor will be triggered, and inside the constructor we have the insert command. Okay, now as we go to the crawler.java, the crawler.java, we have to use the indexer here. Okay, indexer here. Now let's call the indexer equals to new indexer. Okay, and inside the indexer, I need to provide the document object that I've got from the JSON, and I need to provide the URL. Okay, fine. Now as we are printing the system.out, okay, fine. Now let's try to run this application again. Now initially, before this, the crawler was just printing out the page titles whenever it was crawling. Now it is also providing the data to the indexer also. Okay, now the crawler is also providing the data to the indexer. And what indexer is doing? Indexer is saving all of these things to the database, right? Now let's just start the crawler and let's see if all of this is working or not. Okay, so when we run this application, It is going to take some time to run, and you can see whenever we run it, it's going to start crawling over the objects. Okay, read timeout. Let's try to run it again. Okay, fine, it's working fine now. Now you can see that it is crawling over the Java points site, right? It is starting from the Java points home page, and it is crawling over all of the pages here, right? Now what we are doing, we are saving all of the text that is present inside the indexer, right? That is present inside the web page. Okay. If some URL is broken, then it is going to show some error, but yeah, it is not going to get it's not going to exit from the code. Okay, so it is going to take some time. What you have to do is to let this crawler run for some time. Okay, you have to let this crawler run for some time to store the data into the database. Okay, after running the complete code, it is going to look something like this. It will exit with code 0, and when you go to your MySQL and run this command select star from pages, you can see inside the pages table you can get the complete data. Okay, so you can see there are 822 pages, total 822 pages data that we have here. Okay, so that's right, that is enough pages we can use for our search engine process. Okay, that's fine. So that's it for this complete video. The indexer is working fine, and it has already saved all of the pages to the database, right? Now we can use this database that we have prepared for the search engine web application, right? So we'll be continuing with the ranking part in the next section. Ranking. Okay, so let's revisit the search engine design of our web application part on. Okay, so we had our user, right? We had our user. User provides the query, or we can say the keyword, right? User provides the keyword to the front end web application. Okay, to the front end part of our web application, right? Now the front end sends this keyword data to the backend to find the results. Okay, now backend has to read the query or the keyword that is provided by the front end, and backend has to search it in the database, right? Search it in the database. This is our database. Search it in the database. Now this database has been prepared by our own web crawler tool. Okay, we already have 822 pages data inside this database, right? Now what backend has to do? Backend has to look for this particular query. Okay, so it has to run a query. An SQL query, to get the top 30 results. Okay, the top 30 results according to this keyword. Okay, now this particular process is called ranking. Okay, this particular process is called ranking. Now we need to understand this ranking, that what algorithm that we are going to use to rank the pages according to its relevance. Okay, according to its relevance to the keyword. Fine. And then when we get the top 30 results from the backend, we need to just send it to the front end, right? We need to send the results to the front end, and then the front end has to show the results to the user, right? This was the complete flow of our search engine web application, right? The web crawler was only just preparing the database. That was the story of the web crawler only. Okay, but our web application is working like this. Fine. Now let's understand the ranking algorithm that we are going to use in our project. Okay, so there are so many ranking algorithms. Okay, that different search engine use. Okay, some search engines like Google use sentimental analysis, like they understand that what is the context of the text what is the context of the web page, what web page is saying. Okay, so they understand the sentiments. Okay, they understand the sentiments of that. Not sentiments. They understand the semantics of the complete page. So they do the semantical analysis, right? So they understand what web page is saying, right? And after they understand what they are saying, it will index accordingly to it. Okay, it will index accordingly. Fine. But this is our simple search engine project. So what we are going to use, we are going to use a most basic ranking algorithm that we can use. Okay. So in our ranking process, I'm going to count the number of occurrences, of keyword in page text. Okay, in page text, not in page link, not in page title, but in the page text that we have stored, right? Like I told you in the previous video, that with this page text is important to find the relevance. Okay, to find the relevance of the web page to the keyword. Okay, so what we are going to do, we are going to count the number of occurrences of the keyword in the page text. Okay, now you can see with this example here. Now if we have a page, suppose let's say there's a page about Bahubali. Okay, there's a page completely dedicated to a Bahubali movie. Okay, and there can be some another page that is about top 10 movies. Okay, top 10 movies, right? Now in the Bahubali page and in the top 10 movies, in the top 10 movies we have somewhere at the third spot that we have Bahubali here, right? Now which is more relevant to the now suppose if we are searching for Bahubali, now if we are searching for Bahubali here, now which page is more relevant to this keyword? Is if it is the first one that is completely dedicated to the Bahubali movie, or the second one that is just showing the top 10 movies and it has some section for Bahubali? Obviously the first one is going to be the more relevant to the keyword search by user, right? Now you can see that this particular page is going to have more number of occurrences of keyword, right? It's going to have more number of occurrences. They both contain Bahubali keyword, right? They both contain Bahubali keyword, but whichever has more occurrences is going to be more relevant. That is the simple funda of this algorithm, right? That is more relevant. Whichever has more number of occurrences of the keyword, that is going to be more relevant to the keyword. Okay. So how do we count the number of occurrences of a keyword in the page text? That is going to be the algorithm that we are going to use. Okay. Now we need to create a query, create an SQL query, create a SQL query. Now how do we create a SQL query? The idea is simple. What we are going to do, if we have some page text, okay, if we have some page text, right? One thing is that you can wait. If we have some page text and we are having some Java, okay, we have some words Java here it is Java, here a word Java, and here also a word Java, right? Now if we are searching for the number of occurrences of keyword Java, right, one thing is that you can apply a loop, and just check that if this word is equals to Java or not, right? That is one approach. The second approach is that what you are going to do, we are going to replace this Java word. We are going to replace every Java's word, every Java's occurrence with an empty string. Okay, with an empty string. Now this Java keyword will be considered as an empty string. This Java word will be considered as empty string. This will be also considered as empty string. This will be also considered as empty string. Now you can see if we are changing the Java word with an empty string, the length of the complete page text It's going to change, right? It's going to change. And if it is going to change, this will be somehow related to the number of occurrences of Java, right? This will be somehow related to the Java's occurrence, right? Java's number of occurrences, right? And how we can get that? Suppose the complete page text length was n1 before changing, okay? And after changing, it gets to n2, okay? So the change in length after replacing is going to be n1 minus n2, right? Why n1 comes before n2? Because n1 is obviously going to be greater than n2, right? Because we have replaced Java keyword with empty strings, right? So n1 is definitely going to be greater than n2. So this is the change in length, right? This is the change in length equals to n1 minus n2. If what do you say? Is this the number of occurrences of Java keyword? No, right? This is the number of occurrences of what we can say. What is this? What this signify? What does this signify? If we change the length, if we do n1 minus n2, it is going to be something like this: Java, 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 Java. That is the only difference between both strings, right? That is the only difference in the both strings, right? The original one and in the changed one, right? That is the only difference. This is the complete difference because all of these words was changed to empty strings, right? So n1 minus n2 signify this complete string that is of length 12 here, or not 12, 16 here, right? 4 into 4, 16, right? So this signifies the length of complete string that was changed, right? So we need to divide this complete n1 minus n2 by the length of the keyword, okay? By the length of the keyword. If the length of the keyword is L, in this case it's equals to 4, then it is going to be n1 minus n2 upon L. So this is going to be the number of occurrences. This is going to be the number of occurrences, right? Right? In this case, we have to divide this. Suppose if the original string was something like 540 and there was 4 number of occurrences, right? So we minus suppose 524, it becomes 524. So what we do, that we get the change in length, that is 540 minus 524, that is equals to what? 1 6, right? That is equals to 1 6, and upon 1 6 you have to divide this L, right? So L is 4, that is equals to 4, right? So that's how you get the number of occurrences by using this particular formula, n1 minus n2 upon L. Okay, so we need to apply this n1 minus n2 by L formula to get the number of occurrences. Okay, to get the number of occurrences, we need to use this particular formula, right? Now, how can we call this? How can we create a SQL query of this formula? Let's understand that. Let's go to the MySQL and understand how we are going to apply this ranking algorithm. Okay, now what I'm going to do, I'm going to select the length of the page text. Okay, this is the original n1. We can say this is the n1, right? This is the n1, the length of original text, right? If we specify n1 to be length of original, okay, minus length after replacement, right? After replacement upon length of keyword, right? This is the complete formula if I write in the words, right? So we need to just write this. So length of the page text minus length of replaced string. Okay, so replace, let's use replace method for replacing the page text. In the page text, what I need to replace? The Java. Okay, the Java occurrences with an empty string, right? And we need to divide this complete value by the length of Java, right? And this is the complete value that is going to be our number of occurrences. Let's call this value as count occurrence. Okay, from pages. Let's find this value of every page. So now I can see that all of them are showing the occurrences of Java keyword. Okay, and if we select the page title, comma page link also, besides this value, we can get these two. Fine. This is fine. So if we can get this, what we also want to do, these values are not correct as of now. These values are not correct. Why these are not correct? Because this page text, okay, we are just only searching for small Java letters. We are only searching for small Java letters. Okay, to make this formula case insensitive, right? To make this formula case insensitive and get the exact value of Java keywords, what we need to do? Use a lower method to change the complete page text to lowercase. Okay, and then search for Java keyword. Fine. Now all of these pages are going to give me the correct values of Java keyword. Okay. Now, according to this count occurrence, I want top 30 results. Okay. So what I'm going to do, I'm going to first order this, order by count occurrence value. Okay. If I order by this, what it is going to show? It is going to show me the values in the ascending order, but I don't want in ascending order, I want in descending order, right? So if I want in descending order, I need to write the keyword TESC, and if I write this, it is going to show me in the complete page, right? Show me in the descending order, right? Now if it is showing me in the descending order, I need a limit 30. I need a limit 30 here, right? So now you can see I can get the top 30 results according to the query Java, right? So that's how we apply the ranking algorithm. So this is the complete query that we are going to use for applying the ranking algorithm. Is this clear? So we are using the SQL to find the top 30 results by counting the occurrences of keyword in the web page. Okay, now you can see that these are the most things that are most related to the Java keyword, right? So that's how we perform the ranking operation as discussed in the search engine design. So now we need to run this SQL query that we have created in the MySQL workbench, right? So we need to implement this SQL query from the backend to interact with the database and get these top 30 results by using this query. Okay, now if we need to run this query in the backend, we need to use MySQL connector library here also, right? And we need to set up the connection instance with the database also. Okay, so for doing this, let's copy this complete database connection class and save it to search engine project also. So let's go to Java and let's get a new class and let's create database connection class. Okay, and in this database connection class, I'm going to save all of the complete code. Now in this, you might want to delete this package because that was the package in the web crawler, not in the search engine project, right? Now we'll be using this database connection class for running the query, for running the SQL query that we have created here, right? We need to run this particular query from the backend, right? Now, earlier, what we were doing, we were just getting the keyword from the front end and we were just showing the HTML result according to it. Fine. Let's just remove this particular thing. And here, what we want to do is just get the results. Okay, just get the results from the database, right? We need to do this step, right? We need to get these top 30 results by running this particular query. How do we do that? We need to set up the connection instance first. So connection equals to database connection dot get connection, right? And now we want to use this connection instance to run the query. Now how do we do that? Use the connection instance to create statement. Okay, now we need to create a statement and execute query, and inside this execute query I need to run this particular query. Okay, you might notice that we are not using select prepare statement like we did in the last thing. Okay, like we did in the web crawler, like we did in the indexer class. We were using the prepared statement to running the query because we are not preparing the query, right? In the indexer, we need to prepare the query. We need to set these values to these question marks, right? But in our case, we don't need to do that. We just need to create the statement here. And here, what we need to do, we need to run this particular query, right? Now, instead of Java, I'm going to have what? Keyword, and we can use two lowercase to keep it to the lowercase. Okay, and when we do that, here also we can change it to keyword to lowercase. Okay, now instead of Java, we are just calling the keyword that is provided by the front end. Okay, that is provided by the front end in the request.get parameter. Right, now we are running this particular query, and if we need to run the query, we will get these values as a result set. Okay, so result set equals to connection.createStatement.execute query. Okay, now when we get this value as a result set, we need to create an array list. We need to create an array list to save these results from the result set that we have got from the connection statement. Okay, now let's create a user-defined data type. Let's create a user-defined data type that is going to store the results. Okay, so let's call this class search result, and inside the search result class, I'm going to have two values. The first one is going to be the title. Let's call it title, and second thing is going to be the link. Okay, and let's create getter and setter for these. What we need to do, we need to generate and use getter and setter and select all of the values and click on OK. Fine, and let's go back to search servlet, and here we need an array list of search result type, right? Let's call this array list results equals to new array list, and inside this array list I want to do search result. It's going to be of search result type, right? Now what we need to do, we need to iterate over all of the results in the result set while if result set dot next is not null, then we are going to create a new search result. Okay, search result equals to new search result, and this search result is going to have the same value as the result set dot get string, and we need to provide the string. The column label is going to be the page title, sorry. And search result dot set link is going to be result set dot get string, and here we need to get the page link, right? Because we are getting the page title and page link, right? We are getting the page title and page link. So that's why we are providing the column labels of these. We are providing the column labels. That this the page title will be set as title in the search result, and the page link value will be set as link in the search result. Okay, and then the search result will be added to the results array list. Okay, this will be added to the results array list. Now all of these are throwing some exceptions, so let's handle these exceptions. Try. And here let's add a catch block, SQL exception, and after that what we need to do is SQL exception dot print stack trace. Right, now we have saved all of the values in the results array list. Let's try printing these array list. Let's try printing this array list. Search result results array list. Let's try printing this results array list and see that if it is working fine or not. That if we are able to execute this query and save data into the result array list, right? Let's see if it works or not. So let's system dot out dot println, and here what we need to print is the result dot get title, right? And let's add a backslash n and have result dot get link, right? And let's add a backslash n here. Okay, now what we are doing here in the search servlet, let's revisit that. So we are getting keyword from front end, right? From front end, and after that we are setting a connection to database, right? Now we are getting results after running the ranking query, right? After running the ranking query, we are just transferring values from results set to results array list, and here we are just displaying results array list in the console, right? So let's run this application, run our web application. And when we run our application, let's visit the link. And when we go to the link, let's search for some query here. Let's search for Python. Okay, let's search for Python and click on search button. And when we click on search button, it is saying that create statement is null. So connection is null. That is because we have not added the library here. We have not added the library, MySQL connector J library, right? Like we did in the web crawler Java. So go to the library section and add a library from Java. Go to your downloads where you have downloaded your MySQL connector J library and you have extracted it. And after extraction, click this .jar file and click on OK, click on OK, and click on apply and click on OK, and rerun this application. Okay. Now let's try doing this again. Let's go to our search engine web application, and here search for Python again. Click on search button, and when we go to our console, we can see that we are able to get all of the Python results, all of the top 30 results that we are able to get, right? So these are the top 30 results that we have got by running this particular query, right? So yeah, that's all about the ranking implementation in the backend. Now what we need to do, we need to get these top 30 results. We are able to produce these top 30 results by running the query from the backend, right? Now we need to send this results array list to the front end, and we need to display the results on the web application, right, to the user. So what we have done till now, we have our result array list prepared in the backend, right? So we have run this SQL query from the backend and got the top 30 results in the backend. Now what we need to do is to send these results, this results array list, to the front end, and then this results array list should be shown as a tabular format, right? In the tabular format, and after showing this in the tabular format, this will be displayed to the user on the front end side, right? Now what we need to do is to send the result array list to the front end first. Okay, so how do we do that? We need to set the parameter. Okay, we need to set the parameter of the request. Okay, how do we do that? So request dot set attribute. Here we need to set the attribute. So results will be called, if I say results, then it will be the results array list. Okay, so on the request I have set the attribute that results will be called our results array list. Okay, now this request will be forwarded to the front end. Okay, this request will be forwarded to the front end. Let's create a front end file before that. Let's create a front end file for displaying the search result. Let's create a search.jsp file. Okay, now we will be forwarding the request and response to this particular search.jsp file. Okay, so in the search servlet, I'm going to request dot get request dispatcher, and here I need to select the search.jsp file. Okay, and when we do that, we need to forward the request and response, right? Now this forward is going to it is going to throw some exceptions, so we need to handle those exceptions. That is catch servlet exception and servlet exception, and here we need to print the stack trace of that, right? And if we want to do that, we can just catch the collapse. We can just collapse the catch blocks. Okay. After that, we have forwarded the request to the search.jsp file, and now we can get all of the search array, all of the results array list data at the search.jsp file. Now this is going to be an HTML file. This is going to be a Java code wrapped in an HTML file. Okay, so let's create an HTML file. Let's create an HTML structure for that. So HTML, closing back HTML. Inside that, I'm going to have body, closing body, right? So if you start an HTML file, it starts with an HTML opening and closing tag. Okay, and inside this, you have to create a body opening and body closing tag. And inside this, it contains the body of the HTML code. Okay, it contains the body of a web page, and here you define that what is the structure of the web page, right? Now in this, I'm going to create a table. I'm going to create a table with border goes to 2. Okay, let's close this table first, right? And inside this table, I'm going to make a row. So row is defined by tr tag. Okay, let's close this, and I want the first row to be the header row, right? So So I want to specify that what column it is going to be. Okay, so how do we do that? Use the th tag for headers. Okay, use the th tag for headers, and here I want to do what? Title and the link, right? We need to display two values, the title and the link, right? And for the next rows, I want all of the values of the results array list. Now, how do we get the results array list in this HTML code? If I want to write a Java code inside this HTML file, inside this JSP file, I need to use these modulo signs. Okay, I need to use these angle brackets and modulo sign. And inside this, I can write whatever Java code I want. Okay, so that's why JSP is used for writing Java code inside the HTML. Now here I can do what? I can call the array list. I can get the array list of search result type. Let's call this results equals to, how do we get that? Request dot get attribute, and here we need to get the results attribute. So whatever attribute that we have set on the request, right? So results will be called the results array list, right? So that's why in the search.jsp I need to put the same attribute to get the results array list. Now I need to typecast it because type gets changed here. Fine. So we need to typecast it to make it change to array list of search result type, right? Now after doing this, I need to make a for loop, and for every search result present inside results array list, I need to do this. Okay, let's close the Java code, and here I need to create a row, right? For every result I need to create a row, right? For every result I need to create a row, and inside this let's create some values. For values you need to put td. th is used for headers and td is used for values. Okay, slash td. So in the first one is going to be title, and in the second one it is going to be the link. Now let's write the Java code for doing that purpose, right? Now here what I need to do, I need to use the writer. The writer we created here, right? I need to create this. I need to use the response writer. Okay, response.getWriter, and here I need to use the writer to print the result, whatever result I'm iterating upon, right? Dot get title. Okay, so I'm using the get title method, of the search result type, right? So I'm just getting the title of the search result. Okay, and I have to put a semicolon here, right? And same thing will be done for the link as well, but in here instead of title I want to have get link. Okay, now to close this curly braces I need to add another Java code block, and here I need to close the for loop, right? And here our table will be closed, and let's see if all of this works or not. Okay, so before running this application, before running this file, we need to import two things. The first one is going to be @page import equals to java.util.array list. Okay, and the second one is going to be the search result. Okay, it's better to keep this Java classes in a package. So let's create a package first. Okay, let's create a package. Let's call this package com.accio. Okay, and let's move let's move these files. Let's move these files to Accio, com.accio. com.accio, and here let's refactor this. Okay, do refactor, and here in the com.accio package I can find all of the classes here. Now here, instead of search result, I need to do com.accio. It's a good practice to keep all of the classes that are similar, right, to keep it in the package. Okay, fine. After we have imported all of the required files here, we can run this application again and let's see if it works fine or not. So what we have done here, we have got the results. We have already got the results from the database, right? Now we are just showing the results to the front end and showing it in a tabular format. Now let's see if it works fine or not. Now here, let's search for something. Let's search for React here and click on search. Search engine search is not available. Let's see what happened. Okay. Yeah, it has refactored it to this. So make sure when you refactor this web servlet should be at search. Otherwise, in the index.jsp, when you are searching for this particular servlet, it will not appear, right? So make sure this web servlet should stay as /search. Okay, that's why it was saying that search engine /search is not available. Why? Because that was changed to com.accio.search. That happens while doing the refactoring. You should stay alert while doing that. Okay, so this should be same as search. Okay, let's rerun this again. Now let's search for React again and click on search. Now you can see we are able to see the top 30 results according to React, right? React.js tutorial, learn React native tutorial, and React.js tutorial. Here we have a lot of things, right, that are most relevant to the React.js, right? Fine. So our search result is working fine. What we need to do is yeah, there's one thing that we need to update. In the search, the links are not appearing as links. Okay, the links are not appearing as links. They are just simple text, right? So we need to click. We want it to be clickable, right? How do we do that? How do we do that? We need to wrap this link in an anchor tag. Like I told you earlier, an anchor tag makes this particular text, to a hyperlink. And where it should redirect to, that should be specified in the href section. And here we can again copy this particular value. And if I rerun this application again, it's going to work fine. Now if I search for anything again, let's search for Angular. And if I'm searching for Angular, you can see the first one is the Learn AngularJS tutorial. And when I click on Java point site, let's click on this particular link and let's see if it's working fine or not. Right, it is redirecting me to the Java point site. Okay, that is designed for AngularJS tutorial, right? So that's all for displaying results on the front end side, and then the user is able to get all of the results on the front end, right? So whenever I'm searching for something, I'm able to get the results on the front end. Okay, so this is the second major feature of our search engine web application. Okay, so what do we mean by history feature? So it is going to store, all of previously searched queries. Okay, queries by the user. Okay, now how do we store that? How do we store that? So whenever user searches for a query, whenever user searches for a query, it goes to the front end, right? Front end submits this query to the backend, right? To the backend. This is our front end, and this is our backend, right? And then backend applies a SQL query to the database, right? The database, and get the results, right? Get the results, and then these results will be forwarded to the front end, right? And then these results will be shown to the user, right? So this was the complete flow of showing the search results to the user, right? Now, what about history feature? We need to store all of the previously searched queries, right? So whenever user searches for a query, it goes to the front end, and then the query gets forwarded to the backend. Okay. Now we need to create another feature. Okay. There's a search servlet, right? There's a search servlet for getting the search result, right? Now we need to create another servlet. We need to create another servlet called history servlet. Okay. Now this history servlet, it is going to store. It's going to store. It is going to store all of the values. Okay. It's going to store all of the queries. Or we can say it is going to display all of the queries. Okay. Not store all of the queries. Display all of the queries. Why why it is not storing all of the queries? Because query will be stored whenever the search servlet is called. Okay, whenever the search servlet is called, a query will be stored into the database. Okay, so whenever the search servlet is triggered, it is getting the search results. Also, it is storing the query that has been searched in a in a separate table. Okay, let's create another table called history table, right? And then this search servlet is storing the search result, this query, whatever query that is provided by the user in the history table, right? Now history servlet is doing what? It is just displaying all of the queries that has been previously searched. Okay, so it is just displaying all of the values that is present inside this history table. Okay, it is not storing all of the queries, it is just displaying all of the queries. Okay, now uh, for the storing queries, it is going to be done by search servlet itself. Okay, so what do we do? How a history feature is doing? So user interacts with the front end, and there must be a button calling to get history. Okay, now when the user clicks on it, when user clicks on this particular history button, uh, it will be passed to the backend. Okay, backend. In the backend, the history servlet will be triggered, right? History servlet will be triggered, and when history servlet will be triggered, it will get all of the. It will run a SQL query, to get all of the values that is present inside the history table. Okay, so it will get some history results, right? And then this history result will be forwarded to the front end, right? And then these results will be forwarded to the displayed on the front end, right? So this is similar to the search function, right? So that's how it is going to work. It will be similar to the search function, right? Now the query will be stored. Query will be stored at the search function itself, not in the history function. That should be obvious, right? It will not be stored in the by triggering this history servlet. History servlet is just for displaying the values. It's just for displaying the history values, not storing these queries. that has been searched by a user. Okay, so whenever search servlet will be triggered, whenever user is wanting the search results, it will be storing the query also. Okay, it will be storing the query also. And whenever history servlet is triggered, it is just going to display all of the previously searched queries. Okay, now that's it for this video. That is the complete flow of the history servlet, and in the next video we will be implementing the history servlet. So how do we do that? In the IntelliJ, I'm going to create another servlet called history servlet. So I'm going to repeat all of the steps, okay, that we have done in the searching, or that we have done in the search feature, right? In the search feature also, we had similar structure. Query was sent to the front end, and then front end sends the query to the backend, and then backend runs a query and gets some results, and then backend forward these results to the front end, and then front end shows these results in a tabular format, right? Similar thing happens in the history feature also. User clicks on the history button, then the history servlet will be triggered. When the history servlet will be triggered, it will run a SQL query, and it will get all of the results that are present in the history table, and then these results will be forwarded to the backend, forwarded to the front end, and then front end will show these results in a tabular format, right? So let's do the steps again. Okay, in the history servlet, let's mark it as servlet first. So @web servlet. Here I need to add a definition. I need to add a route here for the history servlet, right? And it also going to extend the properties of HTTP servlet. Okay, now in this I'm going to create a protected void to get method. So whenever this history servlet will be triggered, this method will be called, and a set of request and response will be formed, right? And in this do get method, I'm going to do what? I'm going to, whenever this history servlet will be triggered, right? Whenever this history servlet will be triggered, what do I need to do? I need to run a query, right? I need to run a query and get all of the values that are present inside the history table, right? So before doing this, I need to create an history table. Let's go to our MySQL workbench. In the MySQL workbench, I'm going to open it, and in this I'm going to create a table called history. Okay, similar to the pages table here. I'm going to create a table called history. So create table history, and in this table I want two values. First one is the query that we have searched for, right, or the keyword we have searched for. Okay, so keyword, that is going to be of text type. Okay, and the link, so that we can, by clicking on it, we can again go to the search results of that keyword. Okay, so this is going to be of text type. Fine, let's execute the selected portion. Okay, we need to select the database first. So let's use the search engine app. And when we do that, we need to run the selected portion here. So whenever you open your MySQL workbench, make sure you select your database first. Okay, you use your database first, then you run all of your commands. Okay. Now we have already created the history table. Let's try to read values from it. Select star from history, and when we do that, let's run this application and run this command, and you can see we have created a table. In this we have keyword and link, right? Now what we need to do in the history table, in the search servlet, what we need to do whenever we are triggering the search servlet, right? That means we are searching for something, right? That means the user is searching for something. Whenever the search servlet is triggered, that means the user is searching for something. And whenever the user is searching for something, we also need to do one thing. We need to store the query of the user, right? We need to store the query of the user. So when we are getting the results, we need to do one more thing. we need to store the query of user, and for that we need also the connection instance to run a insert command to insert the value into the history table, right? Now how do we do that? We need to use the prepare statement here. Connection prepare statement. Inside the prepare statement, I'm going to run a command insert into history values. Now here I need to enter two values, question mark, colon, semicolon. Let's have it in a prepared statement. Prepared statement equals to this. Okay. Now the first one, prepared statement dot set string. At the first question mark, at the first parameter index, I want the keywords value, right? The keyword the user has searched for, right? And in the last, prepared statement dot set string, the second parameter index, I want the link so that I can go back to the user. I can go back to the search results of that query. Okay. Now how we can get the link of the search results? Now you can see whenever we are searching for something, the link looks something like this, right? So if we are able to see that this is localhost colon 8080 slash search engine slash search question mark keyword equals to Angular, right? When we search for Angular, the link looks something like this, right? And if we are changing this keyword equals to React, it is going to show me the search result for React, right? So the link is going to be something like this. Now what we need to do is to put a link http localhost 8080 slash search engine slash search question mark keyword equals to, and here instead of putting the React's value, we need to put the keywords value that we have got from the request, right? So add the keyword value here. And when we have prepared the statement, we need to execute the update. Okay. Now whenever we are searching for something, it is going to store the query that the user has searched for, right? When we do this in the history section, we need to just read all of the values that is present inside the history servlet. Okay. So now what we need to do is to get the connection first. Get connection. After that, what we need to do, add a try catch block. And here we need to run a command connection dot create statement dot execute query. Inside the query, I need a select star from history. I want to select all of the values from the history table. That is the command I want to run. And where do we get it? We get it in a cell set. Okay. Now, when we get this, you can see that create statement is throwing some exception. So let's catch this exception, SQL exception. Friends track trace. Okay. Now, similarly, as we did in the search servlet, when we got the results from the executed query, we need to transfer all of the values to the array list. Okay. So let's create an array list similar to the search result. Okay. So let's create a new class of history result type. In history result, I want two values. The first one is going to be the keyword, right? And the second one is going to be the link, right? And here, let's generate getter and setter. Okay. Now we have generated the getter and setter for all of these values. Now in the history servlet, what we need to do? We need to create an array list of history servlet. History results, sorry. array list of history result. Let's call this results equals to new array list, and here let's call this will be of type history result, right? Now let's add a while loop. Inside the while loop, if result set dot next is not null, then what we need to do, history result equals to new history result, and here we have initialized the new history result object. Now let's set history result dot set keyword, and this will be of result set dot get string. Inside this get string, I want the column. Which column do I want? I want this keyword column, right? So I need to provide the keywords name, right? Similarly, history result dot set link, and here we need to provide result set dot get string, and column link will be link, right? And then what we need to do is results dot add history result, right? So we are able to get all of the values from the history table, and then we have stored all of the values to the history array list. Okay. Now what we need to do, we have, whenever we click on the history, it will be triggering the history servlet. Okay, so we need to create an history button also, so that the history servlet will be triggered, right? So let's go to index.jsp, and similar to this, we need to create a new form, and whenever we go to this form, the history servlet will be triggered, right? And let's remove this text field because we don't need text field for this particular form, and instead of having a search button, we are going to have a history button, and whenever I click on this, it is going to submit a form to the history servlet, right? Now whenever history servlet will be triggered, it is going to run a query, select star from history, and it is going to get results in the backend. Now similar to search servlet, we are going to forward this request to the front end, right? We are going to forward this results array list to the front end. So request dot set attribute, and here let's set results attribute to be results array list. Okay, and then request dot get request dispatcher, and here we need to send it to history.jsp. We are going to create a history.jsp file. Okay, let's create a history.jsp file. Make sure you are creating these files outside of this web-inf folder. Okay, it is not contained inside this file folder. Okay, it is outside of this folder. Make sure you are creating in the web app folder. Okay, now when you have forwarded this request to the history.jsp, let's forward this request and response. Fine, and it is throwing some exceptions. We need to add the catch blocks. Okay, now if it is adding the catch blocks, we can just collapse the catch blocks, right? Fine. Now we are able to forward this request to the history.jsp. Now if we are able to forward this to the history.jsp file, let's create similar table in the history.jsp also. I'm just doing it again. So these steps are repetitive, right? We also did this thing, did all of these things in the search servlet, right? Slash body, and the body tag I'm going to have what? A table. Let's have a border of 2. Okay, and let's close this table, right? And inside this table, I'm going to create first row of the header type. In the first row, I'm going to have the header. The first one is going to be the keyword, right? The first column is defined as keyword. The second column is defined as the link, right? th. Okay. And the rest of the rows are basically defined by running a loop on the results array list, right? So let's add a Java code for that. Let's add modular signs. And here inside this, I'm going to get the array list. The array list called results. This will be of history result type. Equals to, that will be typecasted to array list of history result type, right? And we are going to get this from the results.get attribute. Which attribute do I want? I want the results attribute, right? That was the same attribute that we have set here, right? Now when we get this results array list, we are going to run a loop. History result, results. Okay, for every result, I'm going to create a row. Okay, now here I need to create a row tr/tr. Okay, and inside this tr tag, I want to create values td slash td slash td slash td. Okay, inside the first one, I'm going to have the percentage signs out dot println, and inside this out dot println, I'm going to have what? I'm going to have result dot get keyword, right? That's how we are going to get the keyword from history result, right? So we are just calling this get keyword method. Okay, the history.jsp, we are just calling the get keyword method here, right? So in the history.java, we have not created the writer, right? So we need to get the writer also. So first of all, we need to do what? Response dot set content type text slash html, and here we need to do what? Print writer out is going to be response dot get writer. Okay, and in the history.jsp, I'm going to use this particular writer. I'm going to use this particular writer to print this result. Okay, similarly, we are going to copy all of this Java code, paste it, copy all of this Java code and paste it here, right? And instead of keyword, I'm going to have the link, right? So that was all. Let's close the for loop bracket. Okay, and that was all about the history.jsp file. Let's also add the imports. Let's copy that from the search results, from the search.jsp. And here, instead of search result, I'm going to have the history result, right? Let's rerun this again and try to run the history feature. Now when I click on history button, okay, it is showing some error. I am unable to compile class of JSP. Okay, there might be some error here. Okay, instead of results, I need to do it request. Sorry, should be a request, not results. right? If this was the only error, let's see. Yeah, this was the only error. Let's see if it runs fine or not. Let's click on the link. Let's click on history servlet. So now you can see the table is empty. Why it is empty? Because we have not entered any of the query, right? Entered because the history table is already empty, right? Now what we need to do is try searching for some other things. So let's search for React first. Okay, let's search for React first, and after that let's search for Python, right? And after that let's search for Angular. Okay, let's go back and now click on history. Now you can see in the keyword section we are having the React, Python and Angular, and we have also the link associated with that query, right? The links are right now not clickable. Let's go to IntelliJ and put this and wrap this in the anchor tag, right? And here href, it's going to be same as the display text, right? So we need to copy this part and paste it inside the double quotes, right? Let's rerun this application again. I'm going to go to the search engine web application, and inside the search engine web application, when I go to the history servlet, it is going to show all of the values of the history table, right? Now you can see we are able to click on the links. Now if I select the second link of the Python, I am able to get the results of the Python. Okay, is that clear? So that's all about the history feature. Okay, that's all about the history feature that we can implement. Finally, we are going to use cascading style sheets to style our web application. Okay, so its full form is cascading styling sheets. Okay, so in this cascading styling sheets, or we can say CSS files, we decide the styling. We decide the styling of the web page. Okay, so what is the background color is going to be, how the text alignment is going to be, how the objects alignment is going to be, what is the font color, what is the font family, what is the font style. That is defined in the styling sheet. Okay, now uh, how do we specify this styling? So there are three ways. Three ways to specify styling. Okay, the first one is going to be by class. Okay, so by class, what do I mean by class? I can specify some part of the HTML code. Okay, some part of the HTML code. Okay, and I can say that this particular code is belonging to class A. Okay, this particular code is belonging to class A, and suppose I have some different code. Okay, I have some different code, and I'm saying that this is also belonging to class A. Okay, this is also belonging to class A. So whatever styling I have specified for class A, whatever styling I have specified for class A is going to be applied on both. It's going to be applied on both of the part of the HTML code. Okay, it is going to be applied on both of the part of the HTML code. Now suppose, for example, we can have a navbar. Suppose let's talk about the navbar. In the navbar, we have the logo of the web application. Suppose we have Google here. Okay, Google's logo here. And suppose we have the login button here. Right? We have not logged in yet, but after a login, the navbar changes. Okay, the navbar is something like this. Log out. the button gets changed. The text on the button gets changed. Now you can see that both are navbars, right? Both are navbar. So whatever, suppose I make a class navbar, right? And I say that the both of these HTML codes are belonging to these navbars, right? Now I can specify styling. For this navbar class, and both of this HTML code will have the same styling, right? So by using classes, we can save time by using same styling, for same type of HTML code. Okay, for same type of HTML code. Now you can see that both navbars are navbars, right? The only difference is the button has been changed. So now if I wanted to have I wanted to have these navbars to have same styling, I can make a class navbar, and I can just make it corresponding to the navbar class, and I can specify the styling to the navbar class. Okay. Now the second way is to do it by ID. Okay, the second way is to do it by ID. What do I mean by ID? So ID is almost same as class. But yeah, it should be unique. For every part of the code. Okay, so if some part of the code is belonging to an ID, okay, it's having some ID, let's say ID 1. Okay, now no other part of the code is going to have the same ID. Okay, it cannot have the same ID, right? It cannot have the same ID, ID 1, right? It should have some different ID, let's say ID 2. Okay, and suppose I wanted to specify styling for only ID 1, I need to do ID 1. Okay, I need to specify the ID 1. Okay, so yeah, I can specify the styling by IDs. Okay, IDs must be unique, but class cannot be. Class can be unique. Okay, can be unique. It can not be unique. Okay, can be unique, also cannot be unique. Okay, so there's no requirement that it should be unique or not, right? Now by third way is by HTML element. Okay, by HTML element, I can specify styling for complete element. Okay, suppose I specify element for each button tag. Now everywhere in the HTML code I use the for each button I can it can contain all of the buttons, right? It can contains many buttons, right? Now suppose I want all of the buttons to have same styling. I want all of the button elements to have same styling. I can specify styling by an element. Okay, I can specify styling by an element. Okay, we don't need to use a class here. We can just specify the styling for every button element. Okay, now how do we specify these things? Okay, so a styling, okay, styling in class is specified by this dot, starting with a dot, and then class name, right? And after that you need to open curly braces and close curly braces, and here you need to define the style. Suppose background color must be equal to red. Okay, that's how we specify the styling here. Okay, ID, when you are using the ID, instead of having the dot, you need to have a hashtag, and here you need to add the ID name. Okay, and after that you specify the styling. In an HTML element, suppose you are specifying styling for a button, then you need to just put button and open curly braces and close curly braces. You don't need to add any of the specifiers before the button. Okay. So that's how you specify all of the styling by using different selectors. Okay. These three things are called selectors. So class is a selector, ID is a selector, and HTML element is a selector. So you can specify styling by different types of selectors. Okay. So that's all for this CSS introduction video.